Good afternoon. Now I'm happy that in the afternoon session that we have there are two lectures. The first session, the second one is two. The first one is Professor K. He is the Deputy Director of the School of Global Management. The other one, the second one is Professor Nika Shah, Department of Mathematics, Gujarati. Next third followed by Pankaj Gupta. That is actually Pankaj Gupta scheduled yesterday, but now today it is postponed. So today he is going to deliver after 3:30 from Delhi University of Goa. Then after that, UPM Kapala, then Dr. Manisha Bhattacharya. So these are the 5 lectures. So now I request Dr. P. Ganesh, who is now the assistant master thesis. So he is going to chair the session. So I am happy to Dr. P. Ganesh. PhD in Ahmedabad University, and the 8th PhD with me was my student. And now I request Hemant Kumar to introduce Ganesh.
Dr. Ganesh sir. So Dr. Ganesh is assistant professor in the Department of Mathematics and Scientific Computing, National NIT, Hamirpur. He did his Master Science and PhD in Statistics from Centenary University, Andhra Pradesh. He worked as an assistant professor at Seshadripuram Institute of Management and also as a guest faculty at the Department of Statistics, Pondicherry, September 2014 to August 2015. He main research interested are areas of multi-criterion decision aid, operation research, statistical classification techniques, big data and data science. He worked on stochastic modeling, time series analysis and forecasting. In gold in SPSS and R. He current research is focused on multi-choice stochastic transformation problems involving fuzzy programming and evaluatory algorithms such as a genetic algorithm, differential evaluation and anti-colony optimization, etc. He has a more than 20 papers, contributed journals and national journals, and presented more than 10 papers in various international and national conferences, and also delivered 6 invited lectures in various workshops and short-term courses. He is an executive member of an Indian Statistics ISPS for the year 2017 to 19 and assistant warden of Boys Hostel NIT Amirpur 2017 to 19. He is a life member in various professional bodies such as the ISPS, ORSI, Indian Science Congress Association of Statistics, Society of Statistics and Computer Applications, International Society on Multi-Criteria Decision Making, and International Society Development of Sustainability (ICDS). Thank you, sir. Thank you, session, sir.
Yes. Thank you, Dr. Hemant. You have taken much time to introduce myself. This to be introduced to speakers. I am very much happy to see Dr. Madhuleti sir. I met him in 2014 when I went to give an interview in Mumbai. So he's a kind heart, and I like my father, like he treated like a new guy in those period, and after that I have joined here. So I am very much fortunate to introduce such a dynamic person to deliver the lecture. So it's a brief introduction about the Dr. Koyilkundla Madhuleti. Now he is a Deputy Director of S.P. Jain School of Global Management and is Associate Professor of Operations Management in Mumbai. And is a visiting faculty to IIM Raipur, IIM Lucknow, Thapar University, Patiala, and different other academic institutions. And he received ASIA's Best Professor in Operations Management by CMO Asia and CMO Council Singapore, and Best Professor in Operations Management by World Education Congress Dubai in the year 2011. And he's a Six Sigma Black Belt and lead auditor. He did approximately 100 crore recurring savings per annum to different companies through the consultancy assistance. So he's expert in production management, applied and business statistics, EQM and Six Sigma, designs of experiments and quality management, operations research and quantitative methods. Sir, kindly go through with your presentation and please share your valuable thoughts to the audience. Please, sir.
Unmute.
Sir, unmute your
Sir,
mic, sir.
unmute modulated.
Yeah. Thank you, Ganesh. Before entering into my presentation, I would like to express my heartfelt thanks to first salute to the Dr. C.R.RAO. No need to tell about his greatness. This is my great salute to him. In his name, we are celebrating here. And the second most important is Rajshekhar Reddy. Sir, thank you, sir, for giving opportunity to me to share my thoughts through this forum. And in the name of C.R.RAO, we are sharing our thoughts and ideas. And at the same time, I would like to express thanks, Ganesh. I don't know what I have done, but you are telling so many things. I won't think so. I am deserved for that. Just that is, as a human being, I might have helped you. Anyway, with this, Reddy sir, I think to tell thanks, I don't know how to express. Just a simple thanks I told to you for giving opportunity to me to share not only today. Earlier also several times you have given opportunity to share. Sometime I might have utilized, sometime I might have missed. I might have told you sorry because of my hectic schedule. But it is your great personality, and you are always try to connect all the people and to exchange ideas, sir. I don't know. I am very very weak in. Even though I have love and affection to express that love and affection. With what words, how to, I don't know. So anyway, thank you, sir, and thank you for your team also who have dedicatedly worked for organizing this event. So with this, without wasting much time, I am entering into my subject. Subject is nothing but data science integrated Lean Six Sigma. I think everybody know. I think most of us we know what is Six Sigma, what is Lean Six Sigma. Then how that if we won't integrate data science, what will happen to Lean Six Sigma? Because automation is coming, there is no scope to improve our by using our traditional tools. There are 100 plus traditional quality tools, 100 plus traditional statistical tools we used to use. But out of 100, 200, we used to pick up best for each project. Maybe different toolkit kit may be required. We used to go and see which are the toolkit I have to use for given problem, for solving given problem through Six Sigma DMIC methodology. Sometimes for a given project, maybe 10 statistical tools and 10 or 15 quality tools may be required. By using these 25 tools, we used to solve problems. That was traditional method. Because of advancement in technologies, several disruptive technologies such as big data, big data analytics, the Internet of Things, then blockchain technology, then IoT, and so on. There are several technologies are evolving because of these technologies. Because the organizations are becoming automation, 100% automation. Because of automation, sometimes traditional tools, if you go with the traditional tools, there may not be any scope. That is the reason we thought of, we are going now with data science integrated Lean Six Sigma for showing a breakthrough improvement in the organizations. So same thing I want to share within half an hour. How it is normally 10 days program we will conduct, but that 10 days program within 30 minutes how to share, I don't know, but I will try my level best to express my thoughts about data science integrated Lean Six Sigma through my PowerPoint presentation. So I'm sharing my PowerPoint presentation to you. With the help of PowerPoint, I can try to give some contribution. some idea to everybody. So now you can see this is the. Are you seeing my slide?
No, sir.
Okay.
Not
So
at
not it. Okay. Well, let me share. I will share it first. Now, are you seeing my slide?
Yes, sir.
Yes, sir. Yes, Bhadretti.
Yeah. Thank you, sir. Thank you, sir.
Yeah.
So this is data science integrated Lean Six Sigma. First, let me try to explain what is Lean, what is Six Sigma, what is data science, then how to integrate all these three. Without integrating, what will happen? With integration, what will happen? We will discuss. I will try my level best to minimize my presentation, maximize discussion with you. Uh, that's why I will complete at the maybe 20-25 minutes later on. I will give mic to you. You can ask questions, and I will try my level best to answer your questions. So first, I'm going to discuss Lean and Lean Six Sigma. Then later on, data science and how to integrate data science with this Lean Six Sigma. We are going to discuss. Now you can see the lean maybe for manufacturing, lean services, lean products, processes, lean systems. These all meaning of lean. If we see, this is very simple term, easy term, and everybody can understand very easily. Everybody, I think several of us we might have implemented also past about lean. It is nothing but simple. It is systematic approach to identify and eliminate waste. So this can be applied in our houses also. In day-to-day work, normally we identify the waste items. I think Diwali in Andhra Pradesh, I don't know, but Maharashtra, entire Maharashtra, in sometime Andhra Pradesh also. In Diwali time, they will identify all the waste. They will throw waste into dustbin. So this is the, but yearly once only they will do. But why can't we can do every day, every month, or once in a week, once in a month, and so on. So only Diwali time they will do entire Maharashtra. They will identify wastages, various wastages in their house, and they will throw it away, dispose it, and they will buy new article in that place. So that means it is very simple. Lean is nothing but elimination of waste. It may be not only a manufacturing system, services, products, process, and systems. Even it is applicable to our own body. See, we in our own body, my body, if I have a more fat, that will create lot of problem. It will lead to even heart attack also. That everybody knows. That's why that most of the yogis, gurus will tell you, please do required exercise, yogas, and so on to maintain lean yourself. So that lean will ensure we can run at faster, we can avoid several risk involved with the excessive muscles or fat, etc. So this waste is either in our body or in our manufacturing area, in our house, or in our process, day-to-day processes, or day-to-day what you can call in organization systems. It is not advisable. This waste has to be identified and eliminated. Further, there are a lot of signs how to identify wastages, how many wastages are there, how to identify wastages, how to eliminate. I think we know all most of the tools, but now slightly different perspective I am giving, how to use data science for doing that. We are going to now in this first line definition, waste is the culprit. That waste has to be identified, eliminated. But without understanding what is waste, it is very difficult to identify waste and eliminate the waste. That's why here a very simple definition is given about waste. You can see here waste definition, very simple. Waste is anything other than the minimum amount of equipment, material, parts, space, or workers' time, which are absolutely essential to add value to the product. Suppose any of the material or part or space or workers' time or equipment is not adding value to the product, that is waste only. So better to eliminate that. Better to eliminate that manpower. Better to eliminate that material. Better to eliminate that equipment. Better to eliminate and space. Suppose excess space you have. Why can't we can hire? Suppose if I have in our organization I need only 1,000 square feet for my employees, but I have 2,000 square feet. Of course, because of nowadays to social distancing, we have to maintain. Now we can maintain. But if that is not the case, then definitely we have to the excessive space has to be rented out or leased out and so on. So that means anything more than required will be treated as waste, and that may be lost to you. Better to use that excessive resources for other. No, I am not telling throw, but you can use it effectively, productively for some other operation. That is the meaning of it. Then waste any non-value added activity in the processes of supply that starts from request to effective execution. Suppose any either service industry or manufacturing industry, once if you get request or order, then you will execute order right from the starting of the request to end of the execution. The any non-value added activity, if you do it, that is treated as a waste. That has to be identified systematically, scientifically, and you have to eliminate it. And nowadays we have data science, how to use that to identify and eliminate. We are going to discuss in these slides. So why lean has to be identified and eliminated means these are the reasons. If you identify and eliminate, sorry, waste, if you identify and eliminate and ensure lean, why that lean will give, these are the benefits to you. So lowest price, the cost reduction possible, improved quality you will get it, and the speed at faster rate you can service your customers and your suppliers, etc. And flexibility, best customization is possible, and the technical proficiency you will get it because of your exactly adequate resources you are using. Now this is the another slide. I think most of you may know. If you don't know, just note down. These are the standard, normally what you can call standard wastages we can see across the organization. All the organization, irrespective of the industry. So all the organization, the overproduction or over service, that production bar service you can use, waiting time, transportation, excessive quantity, and excessive inventory, excessive motion movement of the material within the organization, quality of defects. These all seven waste as per Japanese term they call MODA. And in addition to this, there are other two more terms: untapped resources and misuses. That means you may recruit an employee for as a data scientist and use as a only data entry operator. So that means you are misusing the resource, which is costly resources you are using for very meager one. So this also a loss to the organization. So the Muda, Mura, Muri, these all three together nine we call wastages, and this wastage identification also data science is highly helpful, and not only identification, elimination. So now overproduction, if you use data science properly, the overproduction can be optimal production. It will identify. It will predict your data science. If you use and develop a model for prediction of the prediction for your product demand or service demand, and that will recommend you daily this much only you have to produce, and more than that, that is lost to the organization. Less also you may lose business. So it will identify optimal production, how much you should produce. And if anywhere waiting time is there, unnecessarily waiting, because of data science, if you properly, data science means there are several tools. So you can see there again hundreds of tools in data science. Those hundreds of tools, but all tools may not be applicable to the all the organization. But all the applicable tools of the tools for an organization, if you will identify and properly install across the organization or apply across the organization, it will immediately trigger you. This is the place. The lot of waiting is there for your customer, lot of waiting is there for your supplier, lot of waiting is happening to your material movement, and so on. It will trigger and tell you. The either IoT you can use or some other technologies you can use with the help of data science techniques such as ML, machine learning, deep learning, artificial intelligence, and so on. By using these all tools of the major tools, broad tools I'm telling of data science, this data science properly if you deploy across your organization, and that will tell you here is waiting, there is waiting, this material is waiting. Transporter who has brought material is unnecessarily since morning he is waiting, and so on. It will trigger you like anything with through your dashboards. And that because of that dashboards you have to run like anything. and to remove that waiting time by your supplier, waiting time of your customer, waiting time of your even other stakeholders of business, and not only stakeholders of the business, waiting time of your own material may be one particular station, process station, simply it has come and waiting because of maybe breakdown of the previous next mission. That may be the reason. So this can be captured very easily if you apply data science properly. So, but how to apply, because it is half an hour not sufficient. That is the reason we 10 days program will conduct. So same way transportation monitoring, you can use data science. Excessive processing, if you are doing immediately, it will trigger will come. So you are more than required. You are doing processing. Stop here. This is the temperature is more than sufficient to get best quality of the output. I think temperature is shooting up, which can spoil the product. That is where you will get trigger whenever process will go more than required. It may be heating process, it may be drilling process, it may be boring process, it may be any process in the organization. That can be easily, that excessive process can be identified immediately online, and immediately it will be controlled. So same way excessive inventory, excessive movements of the material more than required, it is moving across your organization unnecessarily. That will say this is value added of process. Why can't you can eliminate it? And quality defects, suppose defects rate is more than, normally now 6 sigma, through 6 sigma you are allowed only 3.4 or 2 3.4 defects in a million opportunities, defect opportunities. So there also, if it will say if you are crossing the limit, immediately trigger will come because of your inbuilt your data science across the organization. This is the way all the 7 wastages can be, which are coming under MODA, can be identified by using a data science properly, what you can call implemented data science. It will identify and trigger you. It will ensure you will eliminate it. Same way, the data science properly if you identify and you can deploy, then untapped resources can be tapped, and untapped resources can be used, that resources and uses can be avoided. So because of time constraint, I am going at fast rate. Later on, you can note down your questions, doubts. You can I can explain you. I can answer you those doubts. Now these are the lean tools. I think these are traditional lean tools, and these traditional tools can be deployed effectively by using data science. I think, for example, the through dashboards, cause and effect will you can arrive through dashboards. You can 5 ways purposes to identify and elimination of the wastages that can be done, and on Azunka, Judako, just in time, Kaizen. These all effectively can be implemented online. It can be implemented not once in a blue moon. Every day, these tools will work in your organization if you apply properly data science across the organization. Now, if you come to the, we have understood what is lean. And lean is nothing but elimination of identification and elimination of the wastages. For that, data science is highly useful properly. But only thing is, in data science, what are the tools and techniques I have to deploy for a given organization? That is more important. That comes based on experience. Now, overview of Six Sigma, you can see what is Six Sigma, meaning of the Six Sigma. Of course, all these things we are not covering because of time constraint, but we can say what is the meaning of Six Sigma, what is Sigma, what is Six Sigma, and how it will be, data science will help here. Those things we are going to discuss. I think you know sigma is the Greek letter. It normally we will use. There are two sigma. Summation sigma we will use. All we are mathematician. We know there is a Greek letter we can use for summation purpose, sigma. Another Greek letter we can use for representing standard deviation. So the sigma, 2 sigma, 3 sigma, 4 sigma means sigma definitely, that means sigma means a standard deviation. If it is larger, the is not good. That is a large variation is there in your process. That is the trigger you will get. So smaller is the better. Standard deviation is the smaller is the better. That means variance is smaller is the better. But sigma capability or sigma level, which we call higher, is the better. More the sigma. That means number of standard deviation which you are accommodating within that 90 95%, sorry, specification limits, that increases, that is good for the operation. I think that you can understand through graphs. I have in my slides the graphs. Through that graphs I will take. Higher the sigma level is better the capability of a process or product. And now you can see what is Six Sigma. If you see the term Six Sigma is a statistical measure of quantifying defects or errors, and at Six Sigma level, a process is producing only 3.4 defects or errors per million opportunity software. And you can, I think, graphically we can understand better. So these are historical evolution and what you can call definition given by various authors, and it is started in 1980s in Motorola and so on. And here Six Sigma, as on today, Six Sigma means, in summary, Six Sigma is a structured and scientific methodology to identify improvement opportunities and define and solve the problems. So that means end of the day, we are going to identify Six Sigma methodology. We are going to identify the opportunities, improvement opportunities, and we are improving the processes. What is Lean Six Sigma? You can say we have seen Six Sigma and we have seen the Lean. If you combine, Lean Six Sigma combines the two most important improvement trends of our times. That is making work better using Six Sigma, and making work faster using lean principles. Lean principle, just now we have seen elimination of wastages. Wastage, if it is not there, big person will become lean, and lean person will run at faster rate. So any organization, if wastages are not there, the cycle time comes down, lead times comes down, the productivity increases, and the more and more you can produce. That is the benefit of. So faster, at faster rate you can serve your customer, and better you will serve, because your defect rate is very low. Defect rate less than 3.4 in a million opportunities mean defect rate very near to the zero. That means best product you are supplying through Six Sigma at faster rate because of lean. So by integrating lean and Six Sigma, the best product at faster rate you are supplying to the your customer. Not only that, the best services you are giving to the all the stakeholders of the business. Now not only customer, we should think, it Six Sigma clearly says that you are not supposed to think only customer. Yes, only customer is the king, we will think about him. At the same time, we have to take care of the supplier. Payment has to be at a faster rate immediately. You have to, whenever you give high quality material, raw material to you, you are supposed to pay in time, on time. So that means at first rate you have to pay to your supplier. Same way, you have to another stakeholder, employee, if you are serving for you at with high quality, with dedication and sincerity, you are supposed to pay is a dues or is a salary or other perks, whatever maybe you are supposed to pay it right midnight, 31st midnight, it should reach in your account, in his account. So that means if you apply this data science properly across along with the Six Sigma and the Lean, definitely it is possible. That means midnight, 31st midnight itself, I will get my salary for 31 days. So that is possible because of data science and integrated with the Six Sigma and the Lean. So this is not only employee, employer, customer, so even society, whatever. Suppose you are supposed to pay income tax to the government of India or government of a country, so that can be paid because of data science. Science will trigger you, even if you want to play. If it is 1 hour more you are sleeping morning, it will trigger you. It will give you alarm. So you are supposed to pay today tax, filing tax and return. You have to return tax returns. You have to do along with this much you do. You have to pay and return, file the return. So that means at a due date, it will trigger you to give right service to your stakeholder. That stakeholder may be, normally you may know only 4 or 5 or 6, normally 15 to 20 stakeholders will be there for every company. You have to identify those 15, 20. Of course, some companies may be 15, some people 20, some people only 6. These stakeholders you have to identify, and you have to serve them with the best quality service you have to give at faster rate. For that, Lean Six Sigma, if you integrate along with the data science, it is possible. So the meaning of Sigma process, if we see it graphically, I can show to you what it means exactly. Now you can see here, large variation, because this we call standard deviation is 2. That means standard deviation can be represented with a small sigma. So standard deviation is a 2. That means, and mean value is 8. And now variation, you can see this is the variation you can see in the process, upper specification and lower specification. There is high probability some of the product will fail because of lower specification, some of the products will fail because of the upper specification. The probability of failure, if you want to reduce, then what you have to do, you have to reduce standard deviation. Now you can see because of standard deviation is 2, your specification width from center to one side 8 to 14, width is uh, 6, one side width is 6. So how many standard deviations you can accommodate? Standard deviation, if it is a 2, 1 sigma, sigma value is a 2, 2 2 2, 3 twos you can accommodate. That means 2 standard deviations, you sorry 3 standard deviations you can accommodate between 8 and 14. 8 and 14, because your standard deviation value is a 2, 2 into 3 times, so 6. The 14 minus 8 is a 6 one side, 14 minus 6 is 2 is the other side. So lower side also 3 standard you can accommodate, upper side you can accommodate 3 standard deviation. That means your process capability is 3 standard deviation process capability. That's why sigma level we call 3 sigma level process. So 3 sigma level process, if you want to make it 4 sigma level process, you have to reduce standard deviation, and your sigma level increases. You can see graphically how it looks like. Now you can see your standard deviation variability in the process you have reduced to from 2 to 1.5. So once you have reduced 2 to 1.5, your number of standard deviation accommodating from average to upper specification, average to lower specification increased from 3 to 4. Are you getting this graph? Are you seeing this graph? Graph
Yes,
is
sir.
visible?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Yes, it is visible.
Yeah, try to understand meaning of sigma and sigma level. Sigma means standard deviation. Most of the people will be confused. Standard deviation higher is very bad, but sigma level is higher is the better. So sigma level, sigma standard deviation it reduces, your sigma level is increasing. So that means more standard deviation you can accommodate between average and upper specification limit, average and lower specification limit. Instead of earlier 4, in 3, in this graph 3, because your standard deviation has reduced to 1.5, you are in a position to accommodate 4 standard deviations in between this center and upper specification. That means your sigma capable sigma level is, your process capability is 4 sigma level capability. That means capability has increased. So the probability of rejection will come down because of your variability has come down and your sigma level increased. Now you can see further we have reduced. So now I think it is standard deviation 1.2 you can bring. So 1.2 if you will put it, that is mistake. 1.07 is there. 1.2 you can assume. If 1.2 if it is the standard deviation, you can, that means you are reduced further 1.5 to 1.2. Now you are in a position to improve your capability from 4 to 5 sigma level process now. The further the probability of rejecting your product further it has come down. So now further if you reduce standard deviation from 1 to 1, 1.2 to 1, now you are in a position to accommodate 6 standard deviations between upper specification limit and center and lower specification and center. This is known as the 6 sigma level process. That means now you can see variability has come down. The probability of crossing your process upper specification and lower specification very meager, negligible. That only 3.4 uh, times it may deviate either up through upper specification limit or it may cross lower specification limit in a million opportunity. 10 lakh if you opportunity error opportunities are there, only 3 to 4 errors will occur. That is the meaning of it. Then we can, I think, note down your doubts. If you have anything, I can clarify later on. So this is precision about precision and 3 sigma, how we have improved from 3 sigma level to 6 sigma level. That is the same curve it is shown. Now we come back to the data science. What is data science definition per se? You can see the process of applying scientific method for acquiring data, building model, validating model, and the delivery or execution of the model to solve a complex business problem. You are not supposed to apply data science a small problem where it is not complex, it is simple problem, easy to understand, easy to solve. So there data science is not required. When it is not manageable with the traditional tools, traditional techniques, either it may be quality tools and techniques or statistical tools and techniques, that time you have to use data science. That's why we normally recommend complex organizations, complex systems, complex manufacturing processes. We will recommend the data science deployment. And once they deploy data science, what it does it's a data science. It is nothing but applying a scientific method for method means it is very thorough. I think later on, later slides, a little bit we can say, and 10 days program normally in depth we can show this applying scientific method for acquiring data, building models, and validating models. Of course, there are acquiring data means after data acquiring and building model, there is in between there are several processes. You have to clean the data, and there are several cleaning techniques depend upon the data nature of the data. You have to choose appropriate cleaning techniques and clean the data. Then that clean the data you will use for building model. And once if you build a model, but again there are several models you can build, but right model you have to pick up, and that right model you have to validate it whether it is working or not. Then if you, after validation only you have to give it for the user community to use that model, or it may be for prediction, it may be for optimization, it may be for other purposes, and that solve the complex business problems, or it may be the optimization it will occur. So of operation, this complex business problem of, it may be that problem may be operations problem or strategic problem also. So those problems it will tackle to achieve predefined goals. Uh, so data science is very simple definition wise, process of applying scientific method for acquiring data, building validation of model, and delivery or execution of model to solve a complex business problem. That problem may be operation or strategic to achieve your predefined goals. Now you can see pillars of data science expertise or data science. Suppose if you want to become a data scientist and you want to apply that data science across the organization to solve a major problem, and you should be thorough with these four pillars. One is business domain, the business or domain knowledge you should have. Suppose if you are applying this data science to a pharma company, pharma knowledge, pharma company, what happens in the entire start to end, you should know. If it is automotive component manufacturing company, you should know about that automotive component manufacturing company. If it is healthcare area, if you want to apply, you should know what will happen in a particular healthcare or hospital. Start patient comes to patient, into patient out, different types of patients, maybe some may be emergency, some may be just casual checkup and so on. So but if you know business start to end, and without knowing business, what is the business is going on, what type of risks are there in the business, what type of deviations occurs in the business, if you are not thorough about the your own business where you want to apply data science, you can't implement or deploy this data science effectively. That is business knowledge or domain knowledge or functional area in which you want to apply that knowledge is most important. Then uh, then the second one is you should be a mathematician. Mathematics is mandatory requirement. Until unless you can't understand what is statistics, what is probability, and various statistical tools, until unless if you don't know the 100 plus statistical tools available are existing in the literature, you can't pick up right statistical tools for a given problem. That is the reason you should know mathematics. That is nothing but includes the statistics and probability. Then the next one is computer science. Maybe you may not be computer science expert, but at least you should know some of the data science related software like R, Python, etc. So software or data architecture or engineering background, little bit you should know, or thoroughly if you know, that is very good. Then the communication, you should have a good communication skill if you want to become a data scientist. Reason is, whenever you see the scope for implementation of data science in a manufacturing or service organization, But until unless if you properly narrate and explain to the owner of the organization or CEO of the company, they can't allow you to deploy the data science across the organization. That is the reason communication skills are required. Because if you have a good communication skills written and oral, then you can communicate with all the stakeholders for successful deployment of the data science. So these four we call pillars of the data science. Maybe you may not be master in the all four areas. Maybe you may be expert in only business knowledge but not mathematics, or you may be expert in business and mathematics but not computer science, or you may have a you are predominantly good in business knowledge but little touch with the mathematics, computer science, and communication, etc. Still it is possible to be a part of. That's why our Six Sigma DMIC methodology will tell every project has to be handled not by individual, a team of people, at least 3 4 5 people. So 4 people means 4 different expertise. So that's why we will take 4 different expertise, and we will ensure that the data science deployment successfully across the organization. But if you have fair idea about all these 4 pillars, then you can be a best team member in the team. Even somebody is suggesting wrong thing, even though he's expert in a particular area, but you can say that no, this is not, better to use Python, not R, because Python has these are the advantages and so on. So even though you are not computer scientist, but you know the knowledge, the more than the based on experience, you can suggest them. That's why this better having knowledge in these 4 areas is mandatory to become a good data scientist. And the data science deliverables, these are the all the deliverables. So prediction purpose you can use classification, recommendations. The normally Amazon and Netflix recommend, it will give recommendation. They have used data science, they have used artificial intelligence. If you go to the Amazon website and try to buy one product, and it will suggest 10 different products, sorry, 10 different similar products which you may like. So that's why this is nothing but recommendations it will give. It is again data science, a major component of data science. That is nothing but AI. They have these people. So that is the reason I think knowingly or unknowingly we all are using, or we are all are benefiting with the data science, especially machine learning, deep learning, and artificial intelligence through our smartphones, through our laptops, through our internet, Google search. You are getting that benefit already, but we are not using in our own organization. That's why what our recommendation is, a top class companies, they have already inbuilt AI and data science in their products and services. Through them we are getting already benefit of it, but we too should use at uh, micro level this data science wherever it is applicable. And pattern detection and grouping, and anomaly detection, the fraud detection, etc. You can use data science. And recognition of, that means images, text, audios, videos, etc. By using this, you can arrive the pattern. You can recognize whether what it is exactly. And that means this data science will help you, especially AI, help you to recognize the images and inner meaning of the images. And for example, if I want to tell, I think data science is the wonderful tool comparatively traditional or manual intervention sometimes. So normally in olden days people used to go with the questionnaire, and sorry, used to send questionnaire and give option, do you like this product or not. You will yes or no, you may give option, otherwise you may give 4 5 options also. Now the a respondent or customer might have put yes, but he might have put yes, you don't know really what degree of yes. Suppose if somebody, if you have gone if you have used data science and you are recording his voice, and then you are analyzing that voice, it will give exactly degree of the acceptability of the product by the customer. For example, if you go to the customer and ask uh, and recorded his voice, suppose our customer say, "Wow, wonderful product, excellent," with the face also, it will capture your facial expression also. And wow, wonderful with the bright face if you tell, and yes, it is good, like that with the you see yes or yes, there is a difference. Yes, yes, it is wonderful. Yes, it is wonderful. It is okay. There is it. there is a tone, there is a difference in tone. If somebody is telling with the pressure, then he is liking product like anything, and is lightly is telling yes, okay, yeah, yes. So it is the tone makes a lot of difference. The degree of acceptability of a product by the customer can be measured by using video recording of his response instead of written responses. Written responses, there is a problem. You can only give yes or no. You might have given question, or you might have given 3 or 4 options. These 3, 4, 5 options, just you might have put tick mark, but you don't know degree of acceptability. But if facial expression, then the tone, if you record it, that the data science will especially I will identify and tell, even though both said same answer, but A said with 90%, 95% acceptability, accepting product, but B only 80% is accepting the product. That difference you can't get in the written questionnaire. But you can AI inbuilt audios, if you collect it, and if you audio videos and process it, it will tell you difference between, even though same words they have told, but the tone and facial expression it will capture and tell that the degree large variation. A is liking more, B is not liking that much.
Sir,
Then
sorry to interrupt you, sir.
action.
Sir,
Hello.
kindly wind up by 5 minutes, sir.
Oh, okay. I will try. I will try to do. Then this is the way the data science will be. This is the process of data science, and the goal setting is most important. Then acquiring data, build the model, deliver the model or optimization is most important. And I think, sorry, one more quickly 2 minutes I will take, 3, 4 minutes I will take for other slides, because I have not shown the. Are you seeing my slide? New slide?
De-
Hello. Are you seeing? 1 minute.
No, sir, not yet delivered.
Yeah, are you seeing?
Yeah, now, sir.
1 minute. Now you can see this is the Six Sigma DMAIC methodology: define, measure, analyze, improve, and control. And each phase data science can be used: defining problem and measuring problem and analyzing problem. The degree of the problem, direction of the problem, you can analyze and measure and improve and control. And these are the deliverables of the Six Sigma DMAIC methodology. We have already experimented each and every deliverable. Data science can be applied. So because of time constraint, I am just rushing through this Six Sigma DMAIC methodology. For getting each deliverable, there are 5, 6 steps. That's the total steps. If you see, there are 50 steps. I may not be in a position to complete, but I am quickly completing because I want to respect the time. Time is more important for us. So these are the already I explained what is data science and pillars of data science and other things. Now you can see there is a similarity in the Six Sigma DMAIC methodology and the process of implementation of data science. The similarity, there is a common things, but the tools are different. The effective, if you integrate both, the effectiveness which you are getting is different. And here in data science there is a control is missing, but indirectly it is there in the control also. That is nothing but through dashboard, designing dashboards and monitoring and control is possible. That normally data science also recommends, even though it has not given in this framework. So I think with this I can close. I want to keep more time for discussion, question and answers. So I'm stopping sharing. I will stop sharing. I'll open for Q&A.
Yeah. Thank you, sir. Thank you for your nice lecture regarding the data science and Lean Six Sigma towards the optimization technique.
Yeah.
So I request any other experts who have any doubts regarding this lecture, please.
You are free to ask any queries.
Good afternoon, sir.
Yeah. Good afternoon, Netra.
Sir, may I know the basic difference between black belt and master black belt courses pertaining to this Six Sigma?
Yeah, the major difference is the number of projects. I think some. Let me tell. There are yellow belt, green belt, black belt, and master black belt.
Yes,
The
sir.
syllabus content wise, the yellow belt, green belt, black belt, there is a difference. Definitely, there is a difference.
Okay.
The normally the green. Quickly, I will take half minute. In the case of yellow belt, basic tools and techniques we will teach them, and we will ask them, they should be in a position to help the Six Sigma teams, like in helper in a workshop, Mestri, you see, the helper will help, spanner 4.2 you give means he will helper will help, like that. These people will give, just help the by basic analysis by Excel. Then in the case of green belt, small problems he will take as a project and he will complete. And black belt expectation from black belt is you should be thorough with all the advanced tools, and major problems you should be in a position to handle by using advanced tools like cluster, factor, multidimensional scaling, canonical, conjoint analysis, and so on. And data science, some of the data nowadays we are introducing some of the data science tools. They should be in a position to use and solve the complex problem by the master black belt. Sorry,
Okay.
black belt. Master black belt normally it is like CEO of the company. You won't become directly CEO. Based on experience, you will become. The same way, after successful completion of several projects, the organizations will give as a master black belt. So generally under master black belt, several black belts will be there, and who are thorough. That means even master black belt itself is a thorough with all the tools and techniques, and he has rich experience and exposure, and what you can call successfully might have completed, and crores of rupees, millions of dollars might have saved to the organization. Such a type of people will be recognized by organization given that master plan.
Okay, thank you, sir.
So,
Thank you, sir.
yeah, thank you, Nita. Any other queries?
Yeah. So,
Okay, thank
Thank
you,
you very much.
thank you, one and all. Then
Yes,
Ganesh, you
thank
can
you.
take over mic.
Sure, sir. Thank you, sir. Thank you for a nice lecture. So now it is over to Professor Nita Shah. So I would like to introduce Professor Nita has received her PhD from PhD in Statistics from Gujarat University. She is the HOD of Department of Mathematics, Gujarat University. She is the postdoctoral visiting research fellow of University of New Boston, Canada. Her research interests include inventory modeling in supply chain, robotic modeling, fundamental modeling of infectious disease, image processing, dynamical systems and its applications, and etc. Madam has published 13 monographs, 5 textbooks, and 475 plus peer-reviewed research papers. And 4 edited books are prepared by the IGI Global and Springer with Dr. Mandip Mittal as a co-editor. So she has guided 28 PhD students and 18 MPhil students, and now there are 8 students are pursuing their PhD under Madam's guidance. She visited different countries like USA, Singapore, Canada, South Africa, Malaysia, and Indonesia to share the knowledge by giving the expert talks. And she is the Vice President of Operations Research Society of India and the Council Member of Indian Mathematical Society. So I request Madam, please share your valuable thoughts in this platform. Madam, please unmute your mic.
Yeah. Thank you, Ganesh.
Thank you, Madhu.
Very big thanks to Professor Rajsekhar Reddy, whom I met after almost 10 years, just before a month. I'm sharing my screen first. Is it visible?
Yes, madam.
Yes, madam.
Okay, good. Professor Madhularthi already said about data science, and partially I will be using data science in this pandemic. So title of my talk is optimal distribution of medical essentials during pandemic COVID-19 through genetic algorithm. So I am using genetic algorithm, that is soft skill algorithm, to find out what should be the optimal distribution of medical essentials. What we had recently observed in COVID-19, almost 11 months are gone, because it was started in December 19 and even today November 19, 21st, but November 19 is just 11 months over. So objective is the need for optimal distribution of medical essentials was observed recently during the outbreak of pandemic COVID-19. Medical essentials were limited and time was very short due to medical emergencies for treating infectious individuals at the earliest. This medical essential comprises of medicines for the infected person, though it was not available, but HCQL and remdesivir were supposed to be given to the infectious individual. But main part was for the medical warriors, who are health warriors, one can say. They need PPE kit to protect themselves. They need number of tools or number of measures which they need to take so that they don't get affected. So this was the very crucial problem which we had observed during last 11 months. So obviously we need to have the planning processes. So the government need to work on number of steps, because this came unexpectedly, and obviously pandemic always comes unexpectedly. So first step is general planning direction. That is how one should start working on it. Then expedite the necessary preparation. And for that, one need to have information. So here is the data should be there. Data from the stakeholders. Stakeholders here can be city. City means municipal corporation, state, and then it goes to main medical hospitals, and it goes to central government. So data from the stakeholders, and the stakeholders, the extreme stakeholder is health government, should be given all the information and notify about the steps to be performed by the state government. And that is what IMCR is doing. Now, second step is orientation. As per the ICMR guidelines, orientation is to execute the action of plan to fight COVID-19 infected individuals. That is how, or what is the criticality of the infected person, and how medical warriors should work. That was guided by ICMR, and that is what has come in the orientation step. And the next step is concept development, because we don't know how this coronavirus can be tackled off. So concept development plays a vital role. In this stage, government needs to determine how the action plan should be followed to realize the transmission of COVID-19 effectively. Now here the action plan, because if you recollect what had appeared in last 11 months, and now once again it has started, like for example, main 5 metro cities, Delhi, Calcutta, Madras, Ahmedabad, Bombay, are once again in the second wave of this infection. So concept development is very important, and government needs to determine how the action plan should be taken up. And one of the action which has been taken by the government, though not only to the particular metros, that they have started giving curfews of hours so that transmission can be reduced. Here, the main objective is the development of course of action. And in remaining part of course of action, we will have COA as the word. Then medical and paramedical warriors to patient analysis is an essential block of this plan. So we need to talk about when concept development is to be made, policy action plan is to be performed. It should be performed for 2 different players. One player is consists of medical and paramedical warriors, and second player is patients. And we need to have a trade-off between the treatment and the infectivity in the society. Next comes plan development. In this stage, health development with medical experts develop the operational plan. That is what to do, where to do, and why to do. That is what plan development is. And that is what AIMS is giving us the planning how one should perform. But with these four steps, we had the concept development, we had planning, we had orientation. But after all, how it is working, that comes under stage 5, and which is plan review. The purpose of this stage is to update the strategies from time to time to cope up with the current situation of the infection. And in the beginning, we used to have review updates of infectious persons, number of infectious person every in every 12 hours clock. But now it comes only 24 hours, so it is under control. But still, we need to worry about, and accordingly, the plan has to be re-executed. Okay. The main purpose of this operational planning process is to find the best way of performing the task to treat infected individuals. Because these infected individuals will cause transmission of infection, and it may be a huge loss, huge human loss to the society, and that has to be reduced. An important element of this is the medical fraternity, as we all know, for the treatment of infected individual analysis. And medical fraternity consists of medical, paramedical workers, cleaner workers, then also the west, you can say lean also, because after all, we had a huge medical waste during treatment of the COVID infected person. So this lean process also one has to concentrate on. So challenge is to allocate COVID-19 hospitals to the patients in such a way that the effective treatment can be provided at a proper time. So this was a major challenge, where to have COVID-19 hospitals or COVID-19 designated centers. And what government has done, depending upon the severity and transmission in a particular geographical area, COVID-19 hospitals, COVID-19 centers has been developed. And that comes under COA, that is concept of action. In the current pandemic, no stakeholder was prepared for tackling it urgently and effectively. We had no clue what to do, what are the medicines available, who will be treated first, because risk was for the senior citizens or the individuals who were having comorbidity, in the sense they might be they were suffering from either diabetes or blood pressure or any other diseases like cancer, or dialysis. They were in dialysis or taking the radiotherapy as a treatment. So nobody was prepared for this. So in current pandemic, it was completely chaos. But still, government has to work it, has to take it urgently and effectively. Let us have a mathematical model, because we now this says say this discussion says that okay, we are not prepared for anything, then mathematical model also needs something to cope up with. Okay, because if I know the scenario, if I know the real problem, then I know some assumptions and I can make a mathematical model. So when optimizing real life problems, and in particular during pandemic, it is often necessary to make simplifications and prioritize to formulate a model that is solvable within the reasonable short time. Because here actually short time was the crucial factor. That is how urgently, how quickly you can treat the patient plays a vital role to control the life of the infectious person and also not to have the transmission in the society. This will have implication on the quality of the solutions. Okay. Not uncommonly, the complexity of the problem makes it very hard to reach the level of simplicity that is necessary to formulate the problem mathematically. And being a mathematician, we know that every time we cannot solve mathematically any real life problem and every time. Okay. So, and if such pandemic comes, it becomes a complex. Okay. In such cases, heuristic solution methods are helpful. And it is also said that heuristic solutions are not optimal solutions of the problem, but still it gives suboptimal solution. That is pertaining suboptimal in the sense pertaining to the scenario, pertaining to the problem, the solution resulted by this solution method can be adopted. And one cannot wait for mathematician to develop a model considering all the critical factors and give the analytic solution, and that was not possible, so heuristic can take a role. In medical essential problems, finding the optimal solution is not necessarily important. So this says that every time to go for a optimal solution by mathematics in an analytic way is not always necessary. In such pandemic, one can go without that also. So the main purpose of a medical essentials allocation tool is to generate alternative solutions quickly because it is about saving of human lives. So we need to here find out what should be the alternative solution. If this doesn't work for this particular area, then what can be the another solution? And that can be obtained only through heuristic approach. It cannot be obtained through analytic approach. Yes. Now, the paragraph says not always, okay, not necessarily important. But in that case, what I can say, a good solution will often be good enough in accordance with the prevailing scenario. So in pandemic, whatever solution I can have or whatever solution can be treated as good one, that is good according to the to fight against the pandemic. During pandemic, the main objective of the healthcare department was to generate alternative solution without wasting time to reduce human loss due to infection of COVID-19. So this is our objective here. So first step is resource constraint project scheduling. So we are using some type of part CPM for management. First one is resource, and here we will be using resource constraint project scheduling. We have resources, but we do have constraints also. Okay. So how to have the combination of resource and constraint to have the scheduling. So let us have n activities and label it as 1 to n. Time horizon of the project is fixed, say capital T, because we believe that as soon as vaccine comes and is given to the individuals, COVID-19 will go away. Okay. So we assume that planning horizon, your time horizon of the project is finite. Duration of each activity is Tn, and here we will be treating it as March, April, May, June, and so on. Now, predecessor activities of activity N is denoted by P of N. There are K resources, label K is equal to 1 to K. Now, these K resources are K COVID centers in particular geographical area. Each resource K has an availability of RK medical essentials in each time period. Time period will be considered as a month. Now, activity N requires RNK units of resource K in each period it is processed. That is how much medical essentials are required by particular COVID hospital. That is what is activity N requires RNK units of resource K in each period it is processed. Now we add two dummy activities, that is two additional activities, say n equal to 0 and n equal to n plus 1, to represent the start and end of the project. Because we all know that if you want to execute project, I need to say when it will get initialized and when it will get terminated. So we are adding two additional activities, n equal to 0 and n equal to n plus 1. These are dummy activities and carry no time duration. So we'll have 0 time duration and do not require any resources. That is, in general, like we used to say that dummy arguments are as good as ideal activities. And my decision variable are binary. So it takes value 1 if activity J is performed by resource K and is finished in time T, and 0 otherwise. So what you can think of, that is how many PPE kit, if X and T I am taking as decision variable and I am taking it as a PPE kit, that is, it takes value 1 if PPE kit is given by source, by resource means by COVID hospital, and when it is required at particular resource, okay, whether it is April, May or June or something. Okay, so objective function is to minimize the project duration. That is, minimize project duration here means to minimize the time so that infected individual can get medication and medical warriors or COVID centers get medical essential in that particular time phase. So objective is to minimize project duration. T stands for time and x of n plus 1 kt, and x and t is already mentioned as a decision variable, binary decision variable, which takes value 0 or 1. K is total number of resources, and in our problem it is total number of COVID centers. Obviously there are good number of constraints. First constraint is sigma over COVID hospitals, and sigma over the time x and kt should be equal to 1. That is, particular COVID hospital in particular month gets medical essentials. So it makes sure, this constraint makes sure that each activity has one and only one starting time. Second one, summation for all hospitals, summation for COVID for particular time, T into x and kt should be greater than or equal to dn plus this quantity. Okay, and this constraint is precedence relation between activities which are handled, and activity n cannot start until all activities in Pn are finished. Now one can treat this as individual cannot start getting treatment until the doctor who is going to treat the infected individual is not prepared with PPE kit. Not prepared because he is not having PPE kit in the hospital. So this condition should get satisfied. And resources and decision variables, that is PPE kits, should always be less than or equal to R of K. And we know R of K is at each resource there is constrained PPE kits available. So this constraint ensures that each resource at any time activities using the resource at that time cannot use more of it than its capacity. That is, if particular COVID center is given as requiring 100 PPE kit in 12 hours, then it cannot exceed this 100. Okay. Now we have a constraint which ensures that I think this is repeated. Okay. Next one. Now both COVID center and particular month, that is Tx and Kt, should be equal. And this Qn actually denotes the set of all parallel activities of activity n. and then this constraint ensures that an activity cannot be performed before all parallel activities may also be completed. And what we see, we have mod, just a minute, we have objective function that depends upon the time and also the decision variable. So both of them are unknown. We need to work out. No doubt time we will take discrete, but x n plus 1 kt can be discrete or continuous depending upon which medical essentials you are working with. If it is PPE kit, it should be discrete in nature, and if it is remdesivir medicine or medical injection, then it can be continuous. And all depends upon good number of constraints. In fact, I have taken only 5, but there are many more constraints, or there may be many more constraints which are involved in it. It was not easy non-linear programming we had with. So instead of solving the problem which I stated analytically, let us see how one can go with genetic algorithm. And one of the main advantage of genetic algorithm is that there is no initial guess of the solution. I did not worry about the initial solution. It uses a search range which spans over the search area. So it finds its own area and then try to find out the solution in that particular area. This makes GA not to worry about local optima. So I will be ending up with the global solution, and which will turn out to be the best optimal solution in particular situation. But this genetic algorithm is actually based on principle from evolution. Just recollect what we had studied in biology, maybe during 11th, 12th standard, or maybe 10th and 11th standard. It is principle of Darwin, who has given principle of evolution. And what is this principle of evolution? That only best survives among all. Okay, and same thing we will be using in genetic algorithm. Taking a population of solution and making to evolve through generations by letting the quality of the good solution survive and letting the bad solution die out. So here you will, in a population, you will have a good number of solutions. Only collect those solutions which are good in the sense which are beneficial for the problem, and just let others to die out, that is, throw it away. In fact, I am doing lean process only. Okay, now in genetic algorithm, main step is crossover. This is the operation that gave rise to new solutions based on the population at hand. In each generation, the population is randomly partitioned into pairs of individuals. So you have one generation, divided into number of individuals, and from these pairs, 2 offsprings are computed. It is like how human being is getting evolved. Okay, so from each pair, 2 offsprings are computed. These offsprings look a little bit like their parents, but they are different. Like it is similar to we people. Our offsprings may not be exactly similar to what we are. Okay? So that is what it says. These offsprings look a little bit like their parents, but they are also different. So here we are not taking care of twins, which are having same qualities. So in this talk, we will be talking about genetic algorithm, but we will use 2-point crossover. That is, at one generation, we will have only 2-point crossover possible. That's why I say twins are not permissible. Once crossover is over, then next step is mutation. And in this step creates activity lists that could not have been produced by the crossover operator. So some of the activities or some of the qualities which were not performed by the crossover then that can be taken care by mutation. And mutation is very important to keep up the variety of the population. Because if everybody likes mathematics in one family, then there is no variety. And it may happen that all family members will get fed up with each other. Okay, so there should be engineer in family member, there should be doctor in family member, because pandemic has at least made us learn that at least one doctor should be there in each and every family, and that can be through mutation process. Okay. Mutation of medical essentials works as follows. For all positions, that is for all hospitals, n equal to 1 to n, a resource with a probability, say P permutation. The source is picked randomly among the resources allocated to the activity. And this resource is interchanged with another randomly picked up resource of the correct resource type. And one can visualize this as the once the patient get infected and goes to hospital, first he is always kept with a normal oxygen, then he is given an oxygen tube, and then he is supposed to go for the ventilator. Okay,
Ma'am,
so that
sorry
is
to
what it
interrupt
says.
you.
Yeah, hello.
Yeah. Madam,
Yeah,
madam, please wind up in 5 minutes.
I'm about to finish. I'm about to finish. Then selection comes. This is what I said. Select or die out. Selection conclude each iteration of the algorithm and a new generation is obtained. Now, we have done with the 8 COVID centers, and they require, this is the time duration in hours, and pre-activities are A5 and A7, and resource type from where they are getting it. And what classical optimization gave me solution as you can see A2, A5, A1 for first COVID hospital. For second COVID hospital, it was A3 and A4, and it was taken in the nearby area. But it says that genetic algorithm switches on A8 and A2. A5 is getting slightly away. Okay, but A3 and A7 are having same activities. So A1, A3, A7 take same number of generations to get the optimal solution, and they take also similar time duration to have the medical association. So hundreds of labs, and run time of this optimization was only 7 minutes using GA. And if even if 7 mathematician starts working on the model, optimal solution cannot be obtained in 7 minutes. Uh, and which was so GA is able to find the optimal solution for small problem, and observe that it runs much faster than the exact optimization model. GA can be used for any size, there is no restriction. Varying mutation probabilities, population size, and number of generations did not show any pattern in which, sorry, did not show any pattern in the variation. And of course, increasing population size increases the probability of finding good solutions. That is quite obvious because you will have a good population. But this also increases runtime, and we were not having runtime. So small size, that is particular geographical area, one can go with and get the solution which is best fit for them. So as a conclusion, we had looked at the possible method for allocation of medical essentials during pandemic COVID-19. It is based on resource allocation method from the branch of project management, and mathematical models of such type are classified as obviously NP hard, not solvable within good time in the sense very short time in this case. So heuristic methods helps to have a faster and flexible suboptimal solutions. Any questions? This is what I wanted to say using
Yeah.
resource allocation problem during COVID-19.
Yeah. Thank you, madam. Thank you for your nice lecture regarding mathematical model of COVID pandemic situation. So I have one clarification regarding this one. So,
Yeah.
madam, is there any specific reason to choose identical algorithm in other evaluation algorithms, because there are so many evaluation algorithms. Why have you
Yeah,
chosen only
I know there are a good number of evolutionary algorithms are available,
yeah.
but we found that genetic algorithm, because we started with genetic algorithm, and
Yeah.
in fact we are working on PSO also, particle swarm optimization, but genetic algorithm gives solution in a faster time.
Okay.
So I use genetic algorithm to explore in this talk.
Okay. Okay. Thank you, madam. Any other doubts? Any clarifications? Yeah. Thank you, madam. Thank you for your nice lecture.
Thank you. Thank you,
Thank
madam.
you, Professor Rajsekhar. Nice to see you.
Informative lecture. Yeah, thank you.
Thank you.
So now we have another speaker, Professor Pankaj Gupta. He is head of the Department of Operations Research, University of Delhi. He visited several universities abroad for academic exchanges and research collaboration. He was a Boycott fellow at different Department of Mathematics, Wayne State University, and doctorate sponsored by Department of Science and Technology, New Delhi. He has published extensively in mathematical programming and optimization, focusing on portfolio optimization, fuzzy optimization, multi-criteria optimization in allocation problems, distribution planning, software design, and supply chain management. So his papers are published in a different variety of well indexed journals. That is, you can say IEEE Translations and in the European Journal of Operations Research and different type of SCA and SCA extended journals. And he served as an editor of several reputed journals. And Professor Gupta received many prestigious national and international fellowships and awards. So I request Professor Pankaj Gupta sir to kindly share your thoughts in this webinar.
Thank you, Professor Ganesh, for a nice introduction. I hope that Neetaji is still there. So, uh, good afternoon.
Pankaj, I am there. I am
Okay.
going to be there.
Yeah, and Professor Rajshekhar Reddy ji, sir,
Yeah, yeah, thank you.
good afternoon to you. Good afternoon to everybody who is attending this session. And
Yeah.
it is really my privilege to be invited by Professor Rajshekhar Reddy to speak in this international webinar. So my talk was scheduled yesterday, but due to some prior engagements, so I had requested Professor Reddy to shift my talk, and he very kindly obliged and put me in this slot 3:30. So thank you, sir, for all your help and coordination. And this is the I mean like this is the right time that people are initiating now the international webinar because of the COVID pandemic. It's not possible to meet physically in a large gathering, so it is very good idea to initiate the international webinars in this webinar series, whether national or international. As far as the talk in this particular session goes, that talk is focused on sustainable transportation, and particular application has been carried out in the mining industry, particularly the coal mining industry. Before, coming to the contents of my talk, let me just briefly, focus on what is sustainable transportation. Although the word sustainable is now very common, and everybody is familiar with the sustainable development goals and all that. Okay, so but broadly, when we talk about the sustainable transportation, so basically sustainable transportation refers to the broad subject of transportation. So we all know what is a transportation problem. So sustainable transportation is basically referring to the broad subject of transportation that is sustainable. Sustainable in the sense of social, environmental, and economic impacts. And components for evaluating sustainability include the particular type of vehicles which are used for transportation, the infrastructure that is used to accommodate the transportation, and of course, we have to look at many other parameters as far as the sustainable goals are concerned. Okay, and sustainable transportation systems usually they make a positive contribution to the environmental, social, and economic sustainability of the communities they basically serve. So here the focus is on sustainable transportation planning in the coal industry of our country, one of the coal industries that we considered for application. So let me just share my screen with you for the presentation part, and I'll pick up the issues one by one and try to explain the issues to the best of my abilities to the audience. So I'm going to share my screen now. Let me just open it. Is my screen visible to all?
Yes, sir.
Okay, so this is the uh, title of my talk, Sustainable Transportation in Mining Industry. And the contents of this talk, it's already published in Resources Policy Journal. And the article is available in the article in press collection of that journal. So so we have basically considered the mining industry in India, and to why to I mean like consider this particular industry. So there are a few reasons behind it. So like mining is a major contributor to the economic growth of most developed and developing countries, and various activities performed by the mining industries, they include extraction of minerals, processing of minerals, and transportation of minerals to the marketplaces. So basically we have looked at that particular part, the transportation of the minerals to the marketplaces. Okay, and if we look at our country's position, so globally India ranks among the top 5 in terms of production of several important minerals, and the overall GDP contribution of the Indian mining industry that lies in the range of 2.5% to 2.75%, and it contributes around 10% to 11% with respect to GDP of the total industrial sector. There could be some variations in the data because the data was collected 2 or 3 years back when the paper was about to be finished. So there could be some variations in the data, but not very large variations are expected. Coal with an established reserve of billion tons is mined the most in the world, and the demand for coal mining is always increasing due to many reasons such as soaring power demands, growing worldwide steel production, and increasingly stringent environment regulations. Regarding the coal transportation in India, so one of the major problems faced by the mining industry for coal movement within the country is transportation for the produced coal due to the lack of availability of proper transportation modes and road connectivity, as generally the small mines are located in the remote rural areas. So there is a problem of connectivity also there. Transportation in coal industry is usually a complex system of interconnected transport links wherein smooth operation of all links of the process depends upon an organized transportation system. So, and then the proper transportation management results not only in the reliability and efficiency of its use, but it also impact the cost of equipment, materials, and resources because it takes care of many things, including the risk of transportation. The major transportation tasks in the mining industry include delivering a total volume of produced coal from the mines to the destinations, to export the byproducts to dump, and transport materials with maximum speed, minimum cost, and greater traffic safety. So when we look at the transportation problem in general, so I hope that whosoever is attending this session, they are comfortable with the transportation problem, because in the classical form, the transportation problem minimizes the cost of transporting some product which is available at multiple sources and it is required at multiple destinations. And then, of course, when we look at the real world transportation problem, it is not just the cost which has to be minimized. There are certain other factors which have to be considered simultaneously. So basically, we can have multiple and conflicting objective functions that can arise in a transportation problem due to the complexity of social, environmental, and economic factors, or in broad sense, I can call these three together as the sustainable factors. So basically, when we look at the classical transportation problem, so we know that what we have to do, as I said, that you have to transport some commodity which is available at multiple sources and required at multiple destinations. And then a natural extension comes for the transportation problem, in the sense that instead of just one product, you can have multiple products also which are available at multiple sources and required at multiple destinations. So there is a multi-commodity transportation problem also. And then there is a multi-objective transportation problem, as I said just now, that by considering multiple and conflicting objective functions due to the complexity of social, environmental, and economic factors. So when we look at the challenges of the mining industry, so the main major challenge, the most important challenge faced by the mining industry are its influence on the environment and the social life related to economic and commercial considerations. Therefore, sustainability and sustainable development have emerged as an important requirement, which should be considered as a priority by the mining industry. Although most of the procedures in the mining industry, they affect environment, we consider only one particular aspect, that is transportation of mining products from the mines to the terminal sites, which has impact on natural environment, of course the drivers who are driving the vehicle, their health and their safety. Then, if we look at the transportation system, the type of transportation vehicles that are used for carrying out the transportation task, so transport systems, they have a significant impact on the environment. For example, the road transport is a major contributor to air pollution and smoke. The increasing use of transportation vehicles in day-to-day life to meet our requirements lead to a wide range of problems such as global warming, environmental degradation, health implications, and greenhouse gas emissions. So those who are living in Delhi city, I don't know how many of the attendees are living in Delhi city. A few days back, it was like a kind of emergency in Delhi because of smoke, pollution, and everything. The emission of GHG from vehicles has a serious environmental impact on health and safety of both the employees and the residents of the nearby community, such as noise pollution, dust and sediment, gaseous emissions, oil and fuel spills, and soil contamination. And hazardous and fatal emissions from the transportation sector can seriously damage global health. It accounts for almost like 15% of the overall GHG emissions and 23% of overall carbon dioxide emissions, which have increased up to 45% from 1990 to 2007, and will continue to increase by about 40% from 2007 to 2030. So this data is collected from different sources, so there could be some variations, so please bear with that. Therefore, it is necessary to develop a transportation system that supports the energy efficiency. So this is these are the issues that I'm bringing up for making a base for the transportation model that we have developed and the integrated approach that we have used for it. So some of the parameters of the ore body cannot be changed, like for example, geographical location of the mine cannot be changed, the political environment cannot be changed, the availability of energy and water, transportation conditions, and the climate. So considering that transportation is usually the most important component of the incurred cost, so nothing can be done to reduce it because of the imposition of mine's geographical location. So we have to look at certain other factors which basically contribute to the sustainable transportation other than the cost, which is basically an economic parameter. With the increased social and environmental awareness, the mining companies, they undertake expensive transportation system. So rather than going for a cheap transportation system that will result in a less cost, so basically it is a multi-objective problem. So we have to look at the trade-off solutions. So we have the mining companies, they are ready to undertake expensive transportation system and compromise on financial viability of the activity to support the fundamental strategy of sustainability. That is, the social considerations and environmental considerations are given almost like equal consideration when they look at the financial viability of the activity. So they are ready to compromise on the financial part to meet the other goals of sustainability. Then the challenge of the urban areas is to promote the sustainable transportation development to prevent the impact of carbon emissions and resource consumption. On the other hand, the population growth and economic expansion lead to a bottleneck. Therefore, sustainable transportation is critical in delivering social and economic demands without sacrificing the environment. So we have to save the environment for the future generations. We cannot sacrifice it for our own sake, like for considering only the economic demands. So we have to compromise on that. So it results in balancing current and future economic development, improving transport qualities and environmental preservation. Then we have in this paper built up an integrated approach where we have considered the prioritization of vehicle types. Then we have also considered the vehicle efficiency. And then, of course, there are the goals like the cost is there, the minimization of the uh, greenhouse gas emissions and other things. So, vehicle efficiency is an important consideration that we have considered in the sustainable transportation. So this vehicle efficiency is basically depending on many critical parameters, which may vary among not only among the vehicle types. That means it's not like I have a biodiesel vehicle, I have a petrol diesel, I have a hybrid type of diesel, I have a battery operated vehicle. So these are the different vehicle types, some of the different vehicle types. So it varies not only among the vehicle types but also on different routes of a transportation network for the same vehicle. For example, like the same vehicle may not be having the same efficiency at different routes. Like for example, some of the routes are very rough where the speed of the vehicle may go down or the breakdown is more like frequent, while on the other route the vehicle has a very good efficiency in terms of not breaking down very frequently or having a good speed throughout or consuming less fuel and so on. So we have coined this idea. It's not that it has not been considered earlier, it has been considered earlier also. So we have basically considered that the vehicle efficiency can vary among the vehicle types, but also for a particular vehicle type on different routes of a transportation network. So the vehicle efficiency has to be considered as an important parameter in the sustainable transportation planning for any particular industry, and in particular for a mining industry in this paper. So efficiency in transport services has been the focus of interest for many years and needs an in-depth investigation. Then when we talk about the different vehicle types, so basically we have to look at those vehicles which are in a sense green vehicles. That means they help in reducing the greenhouse gas emission. So the choice of vehicles to ensure minimum greenhouse gas emission is an important decision in sustainable transportation. And green vehicles usually are the types such as the hybrid electric vehicles, the battery electric vehicles, compressed air vehicles, hydrogen and fuel cell vehicles, neat ethanol vehicles, flexible fuel vehicles, natural gas vehicles, and so on. And for the purpose, they are usually powered by alternative fuels and advanced vehicle technologies. And vehicle technologies may lead to more safety to the driver who is driving the vehicle, the health, the safety of the driver, the comfort of the driver, and other things which can be taken into consideration by using the advanced vehicle technologies for building the vehicles. Some other types includes vehicles using a blend of biodiesel and ethanol fuel or gasohol to reduce air pollution and GHG emissions. So the minimization of transportation cost together with the minimization of greenhouse gas emission from the vehicles in order to fulfill the social responsibility is like of prime importance. So in addition to the traditional objective of transportation, minimizing the transportation cost, there is another objective, that is minimization of greenhouse gas emission from the vehicles used for the transportation. And later on we'll see that we will add few more goals to our problem, so that it is really a multi-objective problem with some stated constraints. So I'll come to that one by one. So then these are the two aspects. One is the vehicle selection and one is the vehicle efficiency. So vehicle selection is basically the vehicle prioritization. So when we have, as I said, like there are different type of vehicles which we can use for sustainable transportation. So each vehicle has its own advantages and disadvantages. So the prioritization of vehicles can be done on the basis of several parameters. which are usually conflicting in nature. And to resolve that prioritization problem or vehicle selection problem, we can take recourse to the multiple criteria decision making. And one of the foremost techniques used for such selection problems is the analytical hierarchy process technique, which has been used in a wide variety of decision making situations. And this also includes the group decision making technique. So we have like decisions made by a group of decision makers rather than a single decision maker. So vehicle selection here is done using the analytical hierarchy process. The parameters on which the vehicle selection is based on, I'm going to come up to that later on. Then the second thing is the vehicle efficiency. And those who are from the optimization field, so they know that to measure the efficiency, one of the foremost technique, the very well known or widely used technique, is the data envelopment analysis technique, which basically measures the efficiency based upon a set of specific inputs used and the outputs achieved. So here, the vehicle efficiency is in the transportation sector. So obviously the inputs and the outputs will be related to the transportation sector only. So data envelopment analysis is used to measure the vehicle efficiency among the vehicle types. Okay. Uh, and of course, for the same vehicle which is used on different routes of the transportation network. Then, as I said, this DA technique is used to empirically measure productive efficiency of several decision making units, and is commonly used in production management and economics. So this is the idea now, keeping all this background in mind. So what we have tried to achieve from this is, we have proposed an integrated approach using AHP and DEA techniques in the optimization of a multi-objective transportation problem, which is related to a mining industry. So of course, mining industries, because the parameters which are used in the prioritization of vehicle, of course, can be broad list of parameters, but the inputs and output used for particular for measuring efficiency using DA, they are related to the transportation sector only, particularly mining industry. So it's not that if we take this approach to some other industry, it will not be applicable. It can still be applicable, but changing a few things like some of the parameters which are related to that particular industry. So the transportation problem here, we have considered several objectives like the minimizing cost of transportation. We, of course, we want the vehicles with the maximum efficiency score. So we have calculated the, we have considered the objective function of maximizing efficiency scores of vehicle types on various routes used for transportation. We have also, we want the vehicles to be chosen with the highest priority. So there is another objective function that we have considered, and that is maximizing weight of the chosen vehicles that have been prioritized. And of course, the minimization of amount of GHG emission from the vehicles used for transportation. And then the multi-objective optimization model is constrained with respect to some important restrictions like the supply and demand, the usual constraints of the transportation problem, the vehicle availability constraints, the vehicle capacity, bounds on minimum and maximum amounts of transported units, and several other constraints. And the vehicle types are prioritized using AHP on sustainability criteria, namely the social, economic, and environmental. And then of course, the input of the DA technique use multiple inputs and outputs. And then we have taken up a fuzzy interactive optimization approach to solve this multi-objective optimization problem to generate the sustainable transportation solutions that meet the preferences as closely as possible. And we also tell on how what is the optimal number of vehicles that can be used for the sustainable transportation goals that have been considered or that have been forwarded by the decision makers to the for the problem. So first thing is the prioritization of the vehicles. So the major influencing factor is the choice of vehicles in the selection of sustainable transportation. And as I said, the prioritization of different transportation vehicles spend sustainability parameters. They helps in obtaining a fair idea of their utility in order to meet the stated goals. Okay, so if we look at the major factors like the economic and social, so obviously we have to consider the prioritization on the sustainability goal. So we have to consider all the three parameters together, so that a type of trade-off solution, that means the vehicle which is not absolutely best in terms of economic, social, and or environmental individual is obtained, but one which is best in terms of all the three parameters together: social, economics, and economic and environmental. So it is a kind of trade-off solution. And most sustainable transportation vehicles, they rely on alternative fuel sources such as electricity, solar, wind, biofuels, and compressed natural gas. So depending upon the type of alternative fuel, any transportation vehicle type has its operational, environmental, and economic strengths and weaknesses. And we have relied on those strengths and weaknesses on the three broad parameters to find out the vehicle selection or the prioritization. So it's not exactly the vehicle selection, because it is going to come through the mathematical model. So it is basically the prioritization. So the weights from the AHP that we obtain, those weights we consider as coefficients of an objective function in the multi-objective problem, where the objective is to maximize the total score of the vehicles chosen. So that is the vehicles with the higher priority, they are considered in the selection. Then, so this AHP evaluation of vehicle types. So as I said just now, we determine the priority weights of the vehicle types, which are maximized in the integrated multi-objective optimization model. And such an approach shall enable to select vehicles that are ranked high. It's not that the highest ranked vehicle would be picked up, because again it is a multi-objective problem, so there is a trade-off solution. It has to be considered in other aspects also, cost-wise, GHG emissions, and of course the vehicle efficiency also. So that means, but we hope to have the selection of vehicles that are ranked high in the AHP hierarchy and also meet other requirements of the transportation problem to the best possible extent. So after making an extensive review of the literature and gathering expert opinions, and a list of criteria was made, and the final list comprised of globally accepted criteria, thus reducing dependence on a particular task of transportation, sustainable transportation. And the broad classification of selected criteria is economic. Under economic factor, we considered cost and fuel efficiency. Environmental, we considered air pollution and noise pollution. Social consideration, we considered safety and comfort. So the attributes, because some of the attributes are positive attributes and some of the attributes are negative attributes. Positive attribute means the more you have, the better is the position, and negative attributes, the less you have, the better is the position. So the attributes like safety, comfort, fuel efficiency are positive attributes, while the attributes cost, air pollution, noise pollution, they are negative attributes. So we want to minimize them, and positive attributes we want to maximize, rely on the maximization of them. So these are the parameters that we have considered for the AHP technique to prioritize the vehicle types, the different type of vehicles which are available for transportation use.
Sir, please finish it up by 5 minutes.
Oh, okay, okay. Sorry, because I was told that it is a 45-minute talk. That is why I was taking it very casually. Otherwise, I would have hurried it up. But
Yes,
anyhow,
sir.
so because my idea was that, like, I was told that it is a 45-minute talk. Okay, so sorry for that. I'm going to just speed up now.
Yes.
So this is so I'm not going to discuss then the attributes in detail. So the attribute like air pollution is there. Okay. Then of course the noise pollution, then cost, safety, comfort, fuel efficiency. These are the attributes that we considered for the AHP evaluation of the vehicle types. Okay. So comfort is very broad, but as far as like comfort, we can talk about the comfort in terms of like the vibration control. So when the vehicle is moving, how much it is, how much vibration is generated. Okay, the leg room, the seat width. So that is basically broadly the comfort zone of any vehicle. So within the criteria, there are many sub criteria also which we can consider to make it more and more clear. Then of course the DA evaluation of the transportation vehicle. So as I said, like the vehicle efficiency is a very important consideration, because it may vary not only among the vehicle types, but also for a same vehicle on different routes of the transportation, the vehicle efficiency may not be same. So we have used the basic DA model. This is the DA model which is used for calculating the efficiency. So we have basically considered the vehicle efficiency from the sources to the destinations, and also destination to sources back. So we have two types of efficiency measures given by the DA models. And then to consider the efficiency on a particular route, we take the average of the two. So we considered the EIJK. This is the efficiency of vehicle type K on a particular link of the network I comma j, and this is taken as the average of the two efficiency scores, which I stated just now. Okay, so basically in one go, for the source I as a target, the efficiency of the vehicle type K on the route I to j can be determined. And similarly, by considering the destination as a target, we again consider the efficiency of the vehicle type K on the route I to j, and then take the average of the two as the vehicle efficiency on the route I comma j for the kth type of vehicle. Then the integrated optimization model. So as I said, we consider four objective functions here. So one is the transportation cost. So you can see that there are n sources, n destinations, and there are different type of vehicles which are used for transportation. So let us assume that s number of vehicles are available. So we have CIJK, XIJK. This is the cost function that we want to minimize. Then we also have the aggregated AHP weighted score. So we have WK. This is the weight of the vehicle type K, which we can generate from the AHP based on those priority criteria, priority factor. And then, of course, this is the transportation number of units transported from I to J using the vehicle type K. So this function is maximized. So this is the aggregated AHP weighted score, which will help us in getting the vehicles which are ranked higher in the AHP ranking, not exactly the highest rank that we are going to pick up. Then the aggregated DA efficiency score. So once again, this EIJK is the efficiency score of the vehicle type K on the route I comma J. And this is the number of units which are transported from I to J using the vehicle type K. So this efficiency score is also maximized. And then we have the aggregated GHG emission, greenhouse gas emission. So this greenhouse gas emission depends on the distance basically traveled from source to destination. So this is DIJ, and this is AK. This is the greenhouse gas emission by the vehicle type K. So this has been recorded by going through our large literature and the reports available from the industry. And this YIJK is a binary variable which takes the value 1 if the vehicle type is used, otherwise for transportation from I to J, otherwise it is 0. And then there are various type of constraints which are used: supply and demand constraints, vehicle availability constraints. So as we deal with different types of vehicle for transportation, so it must be ensured that the number of vehicles used for any given vehicle type should not exceed the availability. So this is the vehicle availability constraint which must be satisfied. So suppose I have only 4 vehicles of biodiesel type, so I cannot use more than 4. Selection of at most one vehicle type. So of course, to carry out the transportation, it is definitely, I mean, like, required to utilize at most one vehicle type. So we won't like to use more than one particular vehicle type on any particular route. So vehicle capacity constraints that are carried out, because every vehicle has its own capacity, so it cannot carry the load more than what it is I mean, like, it is given the flexibility. Then the cardinality constraints. So basically, since the transportation part is usually handled by the third party logistics, so you have to keep check on the number of vehicles also used for the transportation. So we have to keep in mind the maximum number of vehicles which can be used for the transportation network, which will help in maintaining coordinating relations between depot to depot and destination to destination. Then upper and lower bounds in transported units. We do not want to carry very small units of the product in order to, save on many things. So, and then of course integer and binary restrictions. So as I said, that we later on, check solve this multi-objective transportation problem using a fuzzy interactive approach in order to meet the preferences of the decision makers to the extent possible in terms of having those compromise solutions which are meeting the preferences. Okay, and this is the case study that we considered. So one of the industries that we have considered for validating our approach. So challenges are to reach remote areas safely, timely, and economically, reducing product damage due to rough terrain, and use of sustainable and efficient vehicle for transportation. So these were the challenges. Uh, and the mining company has, this is structure. So you have these different sources and these destinations, and you have five vehicle types that we have considered, and these are the supply and the demands. Okay, and then the five vehicle types that we have used: a diesel vehicle, the CNG vehicle, the biodiesel vehicle, battery vehicle, and hydrogen fuel vehicle. And this is the GHG emission per kilometer in gram. This is recorded from the previous data available for such vehicle types. And then AHP evaluation of the vehicle type. So these are the scores of the different vehicles based on the AHP criteria, and this is the modeling of the AHP. And then DA evaluation, we have considered the inputs like time, reliability of vehicle, rate of product being damaged. So this is a very serious concern. And then outputs are operating revenues, freight turnover, and accident rate. So accident rate basically relates to the social consideration like the safety of the driver. So we have, these are the different, input and output data for these different vehicles types. Okay, and then of course the DA efficiency scores that we have obtained, and then the other. So basically the idea was to propose an integrated optimization model for transportation, sustainable transportation goals in mining industry, which takes into account several factors, because besides the cost and GST emissions, we have several factors which are considered in the prioritization of vehicles using AHP. And then, of course, many factors were considered either as input or output in the measurement of vehicle efficiencies using the TEA technique. So I can now, just finish my talk. So if there is any question, I would be very happy to answer to that. So, yeah.
Thank you, sir. Thank you for the informative talk on multi-choice fuzzy transportation problem. Sir, I have one doubt regarding the one. Then you have applied for the AHP in maximizing the efficiency of the vehicle. So you have given the weights of the by using after applying the AHP, you have given the weights for V1, V2, V3, and V4, different types of vehicles.
Yeah.
That weight has been given by either it is a hypothetical or maybe it has been given by some particular company which have been taken by your case.
No, no. The first thing is that the prioritization of vehicle was done on the basis of the certain factors, and those factors I explained what are those factors. Okay, and then of course the information about the vehicle types and those factors that was collected through the records available with the company. It's not that the hypothetical data was used. Okay, so once the AHP calculations were performed, then the weights for those vehicle types were generated, and those were designated as labeled as W1, W2, W3, W4, W5,
Yeah, yeah.
which were later on used in the maximization type of objective function, which was the sole purpose was to select the vehicles for transportation which have high priority in the AHP ranking.
Okay. Thank you, sir. Any other questions from audience?
Yeah, I have one question, Pankaj sir.
Taji,
Sir, can we generalize that for this particular mining,
yeah.
under mining, this vehicle is efficient?
See, it's not like efficiency. As I said, the efficiency is like it's varying not only among the vehicle types, but it is also the routes, different routes of the transportation for the same vehicle. So the idea is that to whichever vehicle, because it's a multi-objective problem and it's an integrated model. So the efficiency, usually when we look at the transportation problem, so we have in each cell of the transportation cost matrix, we have CIJ, which is the unit cost of transportation for taking one unit of the commodity from I source to the D destination. But here, when we construct the transportation matrix, so we have in the cell not only CIJ, but also we have EIJ, the efficiency of the vehicle from the source I to the link J on a particular route. So this way, when
Yes.
overall in the optimization, so this
So the
takes care of
coefficient
so
as
many
multiplied by
things.
mass as well as the efficiency, right, sir?
Yeah. So the idea was to use the vehicle efficiency as an important consideration, because the same vehicle may not, because like for example, if I'm traveling in Delhi, so my car is very good on the route which I take usually from my home to the university campus. But when I travel from my home to South Delhi Park, it's a very congested route. Okay, and there is a lot of fuel wastage and all that. So the efficiency of the vehicle is not same even on the Delhi roads. On my route, I have a very good fuel efficiency, but on other route, the fuel efficiency of the same vehicle is not good. So that means the efficiency of the vehicle is also dependent on the route on which it is traveling. So that is where the vehicle efficiency was considered in the model.
Okay.
Okay, okay. Okay, sir. Thank you.
Yeah.
Sir, any questions, please? Thank you, sir. Thank you for your informative talk.
Thank you, Professor Ganesh. Thank you, Professor Reddy.
Yeah,
Thank
thank
you,
you.
Professor.
Thank you, Pankaj.
Yeah, nice meeting. And thank you, Professor Neeta, for being here in the session, and all other attendees. My best wishes to each one of you. Yeah. So
Thank you.
the session will be continued, or there will be some break now? Hello?
Pardon? Hello?
I'm saying that is this session going to continue
Yeah,
for
continue. Yeah, continue. No break because time is here. Yeah.
yeah, okay. So who is the next speaker?
Uh, Thank you, Ganesh, for chairing the session. Now, uh, I'm happy to introduce Dr. P. Lavanya Kumari. She did, she was, because she did MSc Operational Research and Industrial Statistics. Presently, she is working as assistant professor and head of the department, SP Agriculture College, Tirupati. And she did along with MSc. So she did also PG diploma in computer applications, PG diploma in SPSS, PG diploma in actuarial statistics. For the last 20 years, she is teaching in teaching experience, and she is having a number of 45 papers she has published, and she has attended several workshops and conferences, and and as moreover, she is a life member of Indian Society for Probability and Statistics, and very active member of our War Society of India Tirupati chapter. And moreover, she also when organized this conference 2008 and operational research, she was the joint organizing secretary. I am happy to introduce my own student, Dr. P. Lavanya Kumari. Now I request Dr. Ravanya, please to be the chair for this session. Thank you. Lavanya.
Thank you very much, sir, for introducing me to this webinar. And I welcome all the participants to this second session of afternoon of second day. And I am pleased to have an opportunity to introduce Professor TPM Pakala, sir, as a speaker. In this session, we are having two distinguished speakers. One is Professor TPM Pakala, another one is Professor Dr. Monisha Vardakar. So I am taking this opportunity to introduce Professor TPM Pakala. He is currently working as adjunct professor of statistics at Mangalore University, Mangalore. Initially, he started his career as a lecturer in statistics at Ahmednagar College, Ahmednagar, Maharashtra, and worked from 1979 to 1982. Later, he joined in the Department of Statistics at Mangalore University, Mangalore. He served the postgraduate Department of Statistics in Mangalore University over 35 years. He served at the university as a professor of statistics for a long duration till his retirement. Afterwards, he worked for Justice K.S. Hedge Institute of Management, Nidde, Karnataka, as a professor for 2 years. He served at the Mangalore University in various academic and administrative positions like head of the department, dean of the faculty sciences, chairman and member of several committees of the university, chairman, Department of Statistics in various academic years, syndicate member in academic council, and also as a vice chancellor for a short period. He became instrumental in introducing updated CBSE regulations for PG programs in Mangalore University. He was a president for Association of British Scholars, Mangalore chapter, and he was a president of Vishwamangala Education Society, which runs the courses from KG to UG. During his academic journey, he was awarded a postdoctoral research award from University of New Brunswick, Canada, during 1996 to 1998. During this period, he carried out both research and teaching. He is a recipient of prestigious Commonwealth Fellowship for postdoctoral research, and he also carried out research at the University of Exeter, England for 1 year. He was nominated for the Dr. Alan Stewart Excellence Teaching Award for 1998 for his best teaching at the University of New Brunswick, Canada. Some of his specialized areas are inventory modeling, stochastic modeling, data analysis, statistical analysis for finance, research methodology with the computer proficiency in Excel, as well as in R software. He has more than 50 research publications in reputed refereed international journals like Decision Sciences and European Journal of Operations Research, Journal of Operation Research Society of UK, International Journal of Production Economic, Research, Annals of Operations Research, Applied Mathematics Modeling, Computer and Operations Research, Omega, etc. One of his articles has reached 234 citations as of now. He has delivered 90 talks on various conferences at home country and also abroad, like Hungary, Canada, England, Australia, and South Africa. He also chaired many significant sessions on operations research and statistics. I am very happy to introduce you, sir, and I request you to start the lecture.
Thank you. So I'm going to present on a review work. It's not actually my core research area, but then I thought that I will introduce that. And now let me see. I will upload my presentation. Some problem. Let me see what is happening. Yes, I think I will get it now. Okay. Is it visible now?
Yes, sir. Yes, it is visible.
Okay, thank you. I'm audible?
Yes, sir.
Okay, thank you. Okay, this is a stochastic model for prediction of COVID-19. I will discuss only a few models. There are a number of models that came up in this year, maybe after February onwards. Number of people have worked on these particular aspects. Even Nita has presented a model on COVID-19 only. So we have so many work carried out recently. So I thought that I will give some of the aspects of stochastic modeling. So I will just glance on some of the models, and this may help in the future research. Uh, some youngsters who are taking up this research, this may give an opening. I thought I will mention some of the aspects, some of the dimensions that can help them. Actually affected 217 countries and territories worldwide. As of today, this is the statistic what is I found. So total coronavirus and deaths and recovered and active cases for world and as well as for India. This is as of today. There are different control measures to stop spread of disease. They are like quarantine, using mask and social distance, traveling restrictions, frequently washing hands, sanitizing, or setting body and locations also. Several lockdowns are imposed countrywide. First nationwide lockdown was imposed on March 24th, 2020 this year for 21 days, followed by 19 days and again 14 days and a further 14 days entire country. And depending on certain countries, certain states, it is further extended. In the history of mankind, there are many other outbreaks and transitions of diseases such as dengue fever, malaria, influenza, and HIV virus, and other epidemic diseases. How to build a proper epidemic model for these epidemics and challenging tasks? Some scientists treat the disease spread as a complex network for the forecast and modeling. So it is really a difficult task because of the complex nature and uncertainties involved. COVID-19, some of the models used are SIS, SIR, SCIR models. I will explain some of them here, and many other models are used. Now, I will be using mainly these aspects: susceptible individuals, which means they are not infected, however, they are prone to infect. So, susceptible individuals may become infected or remain susceptible without infection also. Infected individuals already been infected by the virus and can transmit to those individuals who are susceptible, and infected individual may remain infected or can be removed from the infected population to recover, or they may die. Removed individuals are either they are recovered or they become immune, or they might have died. So these are three components in some of the models we use. So three compartments. There are many other compartments. I'm just talking about main compartments, and further divisions are done depending on the research carried out. The first model, or one of the first models, is a Reed-Frost model, which is very simple model. The event probabilities in a given generation depend on the state of epidemic in the previous generation. So it is a Markovian model. These events are specified by certain binomial probabilities. Suppose the population size is young, a constant, which is a constant, and let the numbers of susceptible and new infectives of the generation at time t be x of t and y of t respectively. Then in the initial conditions x0 and y0 is equal to young, and then it becomes xt plus 1, next 1 in the next day or next time point, plus yt plus 1, which is equal to the previous one, xt. Xt is a susceptible. So as the infections and susceptible generations move forward, this is the equation we have. The chain binomial Reed-Frost model has a conditional probability, that is y of j plus 1, next time point j plus 1, given a specific point, conditional probability of that given all the past until the recent one is the same as, this is the Markov property, it's same as unconditional with the recent observations. So this is a standard Markovian condition, and this Markovian condition here is considered by binomial probability x of j, number of susceptible, and y of j plus 1 is what is given here, what is considered here, the number of infected persons out of x of j is given by this relation, where qy is the probability of their getting the infection. So this model has been extensively employed in the analysis of agricultural epidemics such as foot and mouth disease in Japanese beef cattle, tuberculosis in Argentinian dairy cows, and Swedish deer, despite its apparent simplicity. Though it is simple, they have been used. They are simple model. Another simple model used is SIS, that is susceptible, infection, and then becomes susceptible. That means there is no death. So after some time they come back to the, they will recover. The population divided into two disjoint classes. In this one, there are only two classes. And the dynamics of the disease are specified by two functions: the contact rate and the distribution of infective period, how long they will be in that disease, and then they will recover. Susceptible become infective after the contact of this infection, and then they will return to the susceptible because they will be recovered. There is no death assumed in this model. SIS is certainly recover. But SIR model, this is a standard model and simpler model. SIR is quite often used even for COVID. These classes, there are three compartments: susceptible, infected, and removed. Here removed includes both recovered and dead persons. So total is always equal to n in a constant, with not necessarily always, but here it is assumed as a constant in SIR model. There are models where n is different, where people move from outside, or the total, the region itself is expanded. So in that cases, n can be changing. Otherwise, here we assume that n is a constant. So regular, the dynamic, the stochastic models assume the small time point, what happens in a small time, like queuing theory models. So the differential equations are obtained based on the aspects. In a time period t to t plus delta t, s can move to s minus 1 or remain at s. So another possibility, when it is moving s to s minus 1, that means one person get infected. So infected person increases by 1, and each of these infected contacting every person, there is a possibility of meeting with any person, and it is random, purely random. There is nothing like in the model, we assume that it is random. Out of any one person can be infected. The rate is beta. The contacting rate is beta, and encountering a proportion of S divided by N, susceptible person out of N. And it is assumed that the infected individuals recover with the rate of gamma. So that is the recovery rate. This is the infection rate. So beta and gamma are the two parameters considered. So the process ST, suppose we consider only SIS model, you can see that ST and IT are the two states. They represent susceptible and infected persons. So S plus I is equal to N. The probability of infection is during this small time interval, delta t of length is a delta t, then it can be susceptible is decreased by 1 and infected person will be increased by 1. One is decreasing, that is moving to another state. So that probability is considered as beta times STIT divided by n times proportional to delta t and small order delta t. The other complementary probability, that means it remains as it is with the 1 minus of this probability. This explains the probability of moving from the first state, that is susceptible, to second state. Second state is infected state. This analysis is used in a SIS model. Now, it can be extended to SIR model. Now, in SIR model, there are 3 boxes: susceptible, infected, and removed. Wherever here removed means recovery or death. Again, the total is assumed to be constant. N is assumed to be constant. Suppose we talk about only one particular district, then it is constant, and there we can apply. Again, similar to earlier one, we have these conditions. These conditions are very similar. I found that this is very similar to the queuing models. So we have these conditions. The process, I'm sorry. Okay. The probability of an infection and recovery during time point delta t here slightly different. So the first one is same. The second one is S of t to I of t minus S of t A of t. That means there is no infected person. Out of susceptible, no infected person, but there is a 1 minus here. That means it is recovered. So recovery rate. So here gamma is a recovery rate. One infected person is decreased because is recovered. Here recovered maybe, most of the cases it is real recover, and sometimes it can be death also. Both are included in the differential equations. The other complementary probability is given here, and based on this, now from here onwards it can move the finding of differential equations, finding solutions, and then we can estimate other constants. So this is the SIR model. There is one basic reproduction number R0, which is very much used in COVID analysis or even any epidemic analysis. A useful parameter with regard to determine the disease will develop into a large outbreak. R0 is defined as the expected number of secondary cases produced by a single infection in a completely susceptible population. It is important to note that R0 is a dimensionless number and not a rate. It is not a rate, it is a number. How many? Which would have units per unit time. Okay. The dimension describes the state with no other individuals are infected or immune. It is no other means only in this group, only in the group of susceptible we have considered, and no immunization. Because if there is a immunization, then the rate will get changed. That can be considered. Okay, that is an extension of that. Now, what is the interpretation of R0? R0 is less than 1. Each existing infection causes less than 1 new infection. In this case, the disease will decline and eventually die out. Eventually, it will disappear. If R0 is equal to 1, the state will remain in the same status. So it won't be an outbreak, but it will be stable. It will still be persisting. Whereas R0 is greater than 1 is the alarming position where it will increase. It is more than, on an average, more than 1 infection. The disease will be transmitted between people, and there will be an outbreak. The disease R0 value applies when everyone in the population is completely vulnerable to the disease. This means there is no vaccination. If there is vaccination, the R0 value will change. So no one has a disease before. So in second time is not considered here. There is no control of spread of the disease. Once if it is assumed that once some set of control is applied, there is no change in the system. Control can be applied and R naught can be determined, but to that control system. Say, for example, suppose lockdown is imposed, and in that lockdown, R naught remains in one number. Suppose lockdown is removed. During unlock, the R naught may differ because the homogeneity of the nature of the problem will be different. That is the case. So if it is basic, where everything is remaining same, the rate R naught is beta divided by gamma. This is the infection rate divided recovery rate. Say Ian Cooper and others have used the SIR model to compare the spread of COVID in several communities, several countries. So this again, in a recent paper, they consider susceptible population decreases monotonically towards zero. Since epidemics spring up around the globe at different times, the model proposed does not consider the total population constant and take the susceptible population as a variable. Here, they have considered total susceptible population is a variable. So spreading throughout the community, resulting in increasing in the susceptible population. Then the simple three ordinary differential equations are considered, and they get to, in order to get the better understanding of the virus within the community, a variable population time is considered. The number of deaths, D, and recovery are not directly coming from the SIR model. So what they have considered, they estimated D is equal to D naught multiplied by 1 minus e power R K Rm. Rm is a recovery rate, whereas here R is removals, and here Rm is a recovery. I'm sorry, R is recoveries considered, minus, I'm sorry, recovery is equal to total number of removed minus death. That means this Rm includes recovery and death. That is why R is equal to Rm minus D. I'm sorry about the confusion. Okay. Where D naught and K are constant and can be estimated for the situation, for whatever the state, based on the data, and it can be estimated by nonlinear fitting. Given the data, it can be fitted. Now, in another paper, they discussed the time-dependent SIR model. Both transition rate beta and recovery rate gamma are functions of time. Predict the number of infected persons and number of recoveries persons at a certain time point in future. So they can also, after finding the trend, it can be predicted for the future. Adapts according to the change of the control policy. Suppose control policies are changed, or that means, say, there is more immunization possible, then such factors can be included. So lockdown is imposed, then that factors is imposed, or certain strict measures are considered in something like social distance and other factors, and according to the changes, it can be incorporated into the model, and as the time passes, that can be incorporated, and then it can be estimated. And then the data will be obtained, and from that data, curve fitting methods are used, and we can determine the constants or parameters. So in that case, the basic reproduction rate R naught T will be beta of T divided by gamma of T. How do asymptomatic infectors affect the spread of the disease? See, they have considered different aspects. What happens to asymptomatic cases? This was not considered in other epidemics. Here we consider. So two types, again, in asymptomatic infected person, detectable and detectable infected persons and undetectable infected persons. So detectable and persons are considered X1, undetectable is X2. They are type 1 and type 2, and differential equations are considered. So differential equations are given by this, and then we can see that the removals differential equation is given by r of t plus 1 minus r of t is gamma 1 x1 of t plus gamma 2 x2 of t. And this can be written in terms of matrix notation. This model can be written in matrix notation, and it is given by this, where A is this matrix. Such a system is stable if the spectral radius of A is less than 1. The spectral radius can be determined based on the eigenvalues, largest eigenvalue of this matrix, and then based on that we can decide. In this case, there will be no outbreak. On the contrary, if the spectral radius is greater than 1, there will be an outbreak, and the number of infected persons will grow exponentially with respect to time. So then R naught is based on the combination of these two. So this is how modeling gets changed. Now, similar model is discussed for herd immunity. What is herd immunity? Herd immunity is when most of the population is immune to the infectious disease. If most of them are immune, then it is called a herd immunity, and it corresponds to the reduction of number of susceptible persons in SIR model. Now here, number of susceptible persons will be reduced because of that much people are immune, so it is going to be reduced. For the analysis of herd immunity, we assume that there will be the probability H that the randomly chosen person is susceptible at time t, and 1 minus H fraction individuals are immune to the disease. This is incorporated in the analysis. There is also, I will go quicker because there is a lot of slides remaining. I'll just mention various dimensions. There are IC model, that is a independent cascade model considered for propagation, and based on this it is modeled, and N.K. Srinivasan et al. So I have just taken this sentence from their paper. According to WHO, the causes of infection within the population external to the population are called as a local population, and imported cases, local population and imported cases. These two are external and within that. They call them as endogenous and exogenous. So this paper, Shivaraman discussed about paper with endogenous and exogenous spread of infections. So these two are incorporated into the model, and this is the differential equations considered, and they carried out simulation for this work. A susceptible nodes can catch the infection from only those infected nodes. So there are two different aspects. One is endogenous and exogenous, and based on that it is considered, and they have applied these to 3 states, Tamil Nadu, Rajasthan and Kerala. The reason for this, Tamil Nadu is where exogenous is less than endogenous. Endogenous is less than exogenous, and whereas in Rajasthan, endogenous is greater than exogenous, and in Kerala it is almost same. So that is why these 3 states are considered, and based on this model is done. Another work carried out by Ashutosh Simna, they have considered, they are all from Netherlands, but they considered several countries in Europe and also Karnataka. The reason is that because these Karnataka state alone, if they consider, the population is equivalent to some of the population in European countries. That is why they have considered these states with the Karnataka and France, Italy, and these numbers. And these are differential equations, and they have included EF is a exposure factor, and based on that they carried out work. I will leave the details. I'm just giving you various dimensions. But one of the factors I found in this one is they have considered viable process as incremental one. You can see that DWT, that is a viable, I'm sorry, Wiener process. Wiener process, Brownian motion process. Wiener process is considered for the error terms or the variation terms. Where error terms or variation terms modeled using Wiener process, and this is the speciality of this model. And then RFT also comes in because of the infection rate is modeled through Wiener process. The removal rate also incorporated that factor. So based on that model, they have worked out, and they got that the parameter SR model optimized based on the data obtained from different European regions and Karnataka. They have taken for Italian, German, and France and Spain, and based on that, and for different exposure factor, they have uh, analyzed the data. The SIR model has been simulated and parameters have been optimized based on the infection trends obtained from these countries. They have used the forecasting models, and here we can see that the actual data is given in dotted lines, and the forecasted SIR model is given in the broken line. So these two are for the current cases, and outcomes, recoveries and deaths given in the second figure for the France, and similarly for Karnataka is given here. So this is what they have done analysis. Suggestion is that it is inevitable need for extended lockdown period for several months for Karnataka or until a vaccine is available. According to them, they suggested to extend the lockdown. But certain lockdown results are given here are not able to match with that because of the lockdown was not properly implemented, not implemented according to their suggestion. That's why the results do not match. Another paper in SIR model has 4 components where yes, susceptible, exposed, infected, and recovered. This is a standard SCIR model. There are many of the SCIR models that is considered. So here the difference is that they may be exposed, but after exposing they may be infected or may not be infected. So that is one state where they remain for some period, and then it will be detected whether they are infected or not. That is the difference, and that difference is taken into consideration. So there are also other variations in that, symptomatic infected, pre-symptomatic infected, and and then detected and undetected. These are considered. All variations are considered, and you can see that in the figure: susceptible, exposed, asymptomatic, and pre-symptomatic. And again, asymptomatic, they are detected, undetected, and in pre-symptomatic, late detection and detected. These are the variations considered. So we have 8 variables and 10 parameters. The two main intervention schemes for controlling pandemic are social distancing. This is what they are findings: social distancing and testing, quarantine. They have to undergo test and then quarantine. Lockdowns they have suggested, and social distance they can reduce, of course, which is known to us. Testing quarantine means there is an extra channel to remove people from infectious population. These changes in the parameter hence there is a reduction in R0. If these changes are implemented, there will be reduction in R0. Some conclusions of their paper is the larger magnitude of corresponding to the fastest suppression of pandemic is obtained by quarantine, and also social distance. They have given
Sir,
conditions.
sir, request to
Yeah.
conclude within 10 minutes. Another speaker
Okay.
is
Okay.
also waiting.
Okay. Okay. Thank you.
Please, sir.
Yeah. Yeah. Right. So India, given huge economic and social costs, implementation of hard social distance is very difficult. So weaker social distance is actually practiced. Uh, the intense quarantine might only be practical way of controlling the pandemic. Further suggests that a sustained and targeted testing of quarantining strategy combined with some level of social distancing has to be implemented at the earliest and fullest extent. Um, so these are given. Actually, this is work carried out June, and they have given some prediction also. Um, there are also another model SVIS, that is susceptible, vaccinated, and infectious, and again coming back to susceptible. So these models are also considered, and there is also another model, uh, Ashutosh Mahajan and others, susceptible, exposed, symptomatic, purely asymptomatic, hospitalized, quarantined, or recovered and deceased. These models are considered, and based on the data, it is not difficult to estimate the parameters, though there are so many factors based on the data. And uh, as today morning, actually, simulation was explained by Chakravarti, Professor Chakravarti, and simulation models can also be used, very, very useful. They can be applied in a complicated structure. So these are the differential equations for these, and these are the results obtained. Okay, I will not go into the detail. Uh, Again, in one of the cases, like mainland China, WHO situation report, the National Health Commission of the Pe- Pe- People's Republic of China and Health Commission of they have given the inferences are drawn on the effectiveness and intervention of measures, including quarantine and isolation. They have estimated required effectiveness and interventions in order to prevent. So they have used SCIR model to take decisions on this. And this is a diagram how various aspects. There is also quarantine here, without quarantine. So there are two aspects, with quarantine and without quarantine, hospitalized and other treatments. All these are considered, and then consider the model. So these are the differential equations. I will leave out the mathematical. So model based method of estimation is carried out. So they have done MCMC approach, and actually adaptive metropolis Hastings algorithm is used in the MCMC, and they have uh, determined this constant. And likelihood based method of estimation can also is also used. So this is how it can be done. So that is one method. And Vikas Kumar Sharma and Unnati Nigam, they have considered a growth curve using regression methods, exponential, linear, and polynomial, and they proposed optimal model for fitting the cases till May 15th. Further, they proposed use of time series models for forecasting future observations of. They have attempted best fitted. So what came out is best fitted is ARIMA model, forecasting COVID-19 cases. They also compared the results with exponential smoothing. The study will help to understand the course of spread of this virus. And this is the spread of disease they have considered. And there is a change point, growth curve, when they consider, whenever the control measures are taken, then there will be some change points whenever, because of that, these regression models are considered with the change points. These are the parameters, and the ARIMA models are also empirically analyzed. And so the simulation model is also considered, So simulation model can be considered based on the inputs, how they are going to change, and say quarantine strategies, social distancing, lockdown, and testing and variation. If one place we carry out the simulation model, in another place the inputs will be varying depending on these control measures, and then the simulation can be carried out. So I have discussed various aspects of this model. It can give some insight into variety of modeling. There are a lot of other uh, other models worked out. I only picked up some of them. I've given a brief discussion of this. Open it for open with questions and discussions. This is only a part of it. There are a lot of machine learning, and as Neeta has done, genetic algorithm, all those things are used. It's widely used. But the number of papers came up, I have seen that it is huge number. Okay, thank you. I will.
Thank you very much, sir,
Yeah.
for a vast reviewed informative lecture. And this is time for questions. If anybody want to clarify their questions, one or two questions may be permitted.
I have. It's a good review, Pakalla sir. You have covered almost all the models which me and my teammate has derived. So thank you. Thank you for review.
Thank you, sir. Now we have another distinguished speaker with us.
Oh, because it was. Sorry. Okay.
Thank you, Bakala. Yeah.
Yes.
Yeah.
Yeah.
Okay. I am very happy to introduce another distinguished and dynamic speaker of today's session, Dr. Monisha Vartakarji, working in government sector of business at Infosys Limited. Dr. Monisha ji is an accomplished professional with a career spanning over 20 years in information technology and public policy sector. Dr. Monisha is currently handling large-scale IT transformational programs in the government sector as part of India unit at Infosys Limited. She has done her PhD in operations research and is associated with ORSI, OR Society of India, for more than 2 decades. Title of her interesting PhD thesis was Root Choice Problems Using Lexicographic Search Method. In the field of OR, she has published and presented number of her thesis papers in the national and international journals and in forums including ORSI, IIT, and Asia Pacific OR Society, Melbourne University, Australia. One of her thesis paper bagged the Best Paper Award in IIT, Powai, Mumbai. And she did MSc Statistics from University of Delhi, PhD in Goa, and the MBA in International Business, Ford School of Management, Nottingham Trent University Executive Education Program on Government Relations and Public Affairs from Graduate School of Business, Stanford University. Moreover, she had the privilege to interact with the living legend and renowned statistician Professor C.R.RAO when he visited Delhi University during her MSc. Very happy to known from you, ma'am, and I am very happy to introduce to this audience, and we are eagerly waiting for your lecture. Thank you very much.
So much, ma'am, for your kind words. And also thank you, Professor Reddy, for inviting me, because I think I am, only one from the industry. Rest have done great work in this field. I have not missed even a single session since yesterday. And because it's a great learning for me. Other than, I am just a statistics and OR student, but after completing my courses, and I'm interested in all these fields, I try to read and all, but I have not done any further research. like every one of you are doing. So it is really a very good feeling that I am actually being part of someone which I'm actually, I don't think I deserve to be, but it's really a very enriching experience for me, and I will definitely go and share with all my colleagues at Infosys. See, at Infosys, we have been doing large IT transformational programs like income tax, then MCA, Minister of Corporate Affairs, GST network we are implementing, India Post. So all these we have been doing, and everywhere it is actually all our technocrats are starting from whatever you have been saying last 2 days, whatever you have been, I've been hearing. Everything is based on OR and statistics. So I was also asked to give, take 2-3 sessions of our engineers, because today Dr. Professor Madhuleti, he talked about, when he talked about data science models, first is the domain, second is the statistics, third is the architect and engineering. So all these architect engineering, straight away they have gone and not really have very basics of data science, which is a part of statistics and OR. So that is the key where it is needed in all IT, AI, wherever we are going. So although in all the large scale transformational programs, we are kind of starting with basic, having designing the platform and the application. So but once the application is built, once the design is in place, then the next part is your analytics. So where all these AI analytic modelings, etc., come up. So I have a small, small presentation. I'll try to finish off at the earliest possible, and I'll try to share my presentation. 1 minute. Can you see my presentation?
Yes, ma'am.
Okay. To start with, I would like to share my photograph, which I will, it's a lifetime treasure for me. Professor C.R.RAO sir came in Delhi University when I was doing my MSc. It's the Art Faculty, University of Delhi. So there, sir came for a lecture, and he interacted with each one of us. And he asked which state you come from. I come from Assam. Some come, some of them are from South, some of them are from West Bengal, and ask each one of us, how do you feel coming to Delhi, doing this from outside home. I mean, why I'm saying is, even small things he kind of touched upon. Otherwise, we had little fear before meeting him that he's a great professor. We don't know whether we'll be able to talk. Maybe he'll ask us strict questions, but he was not like that. So that experience, for a little while though, it will remain with us forever. So that's what I wanted to show this slide. Then I will not talk about basis or whatever in analytics. We do take part of OR and use OR or statistics, but I only want to touch upon what we do at Infosys and all other business leaders. Nowadays they adapt these OR techniques for all the analytical methodologies for Amazon global supply chain, and to deliver faster route, cost effective route. They've been anyway implying this, and your deep learning neural networks, everything is based on optimization and simulation. So when what we do for our customer, as I said, the ministries also, first we see how the data is managed. We first do AI adoption at the three different stages we have. We have data management and optimization, data management and digitization. Then we have the optimization phase, and then the more operationalized phase. How the operationalized meaning, how to move to analytics. First you develop the application, then you manage the data, and then you do the operational, operationalize it. So, and also the other thing which we are talking at Infosys is, we have a theme called Navigate the Nest and Next. If you see Infosys logo below, down below it's written Navigate your next. That means you have to think always about tomorrow. today is something, its world is moving so fast, you always have to see what is coming tomorrow. So, and then entire, enterprise has to be live. So, say that to other customers, we have done ourselves in at Infosys. So, entire work, now we are working from home, but before COVID came in, we were enabled to work from anywhere, from the airport, from, from the road, or in the client locations, anywhere you can actually, through a mobile app, you can submit your proposal, you can offer services to the client, and then you can approve a document, submit a document. Everything is possible through this live enterprise model. So how there are few phases of live enterprise what we talk about. I'll just tell you these experiences that we have. First is and your basic infrastructure we have to built in. We call it hybrid cloud or polycloud. Polycloud is our product where we use multiple, private cloud, or your public cloud, any through Amazon services, or through IBM, or through your as Amazon Azure, and then AWS is the other one is Microsoft. Sorry. So different kind of cloud services are associated with us. Through them, we have developed the basic, architecture of the infra. So this is the when we say hybrid infra, it is about actually talking about how you operate across multiple clouds, because some cloud is providing some services, other cloud is providing some other services. So through this you will be able to offer all kind of services that is needed to you. And second is the after you do this, the second is the you have to modernize your apps. You have to modernize your entire application system. Once your infrastructure in place, then you modernize your application. How do you do that? You have to have a, we call it, different terms are used, like refactoring. Refactoring is how do you systematically improve your code. Everything is done in an agile mode, and because it's moving so fast to today, yesterday what we thought, tomorrow it will be changed. So we have a tool to refactor every code in such a way that you don't have to redo, you can just modify and upgrade your code. So that is one tool that we've been using. And the second one is important one is containerizing, where you have to containerize all your processes that you have, what kind of data you need, what kind of learning the data got, and then you do that. And then how do you last in apps we do the entire legacy system is migrated to cloud native architecture. So whatever data we had in a server, entire data is shifted to the cloud native architecture. So that's how we do the modernized app. So in hybrid, and then you have the modernize here. You all the system is modernized. One that is done when you have the very apt and modern application. The next step is your intelligence. How do you get intelligence out of it, or AI out of that? So we call that is the heart of live enterprise, actually, which is the AI. So it has the ability to sense what is happening across the IT landscape. What data has come in. For example, as I said, when I submit any document, when anyone submits for my approval, or when we offer any services on real time basis, it actually captures all information from across different sources it has. And then on real time basis it does the analytical, it throws the signal, which makes sense for the user. And we use like vision. I will talk about visions, and speech, NLP, digital brain, what we have here in AI, so that you on real time basis you get all information that you need. Then it also enables making routine intuitive decisions automatically. Many of the decisions are automatically taken. You don't have to. For example, if some of the approvals I submit, then I may not wait for someone to my immediate manager to approve. Or if somebody sends to me for approval, that person did not wait for approval process to be completed. The system knows what is automatically to be completed and approved, and it does that. This is just an example. Similarly, there are many processes which are automated in the system, and then you don't have to actually wait for any manual intervention to happen. So next is experience. Once we have the intelligence in place, then the experience again is what I just now said, that wherever you are, you can also, we have a Lex portal, training portal we call it, learning portal. So there, yesterday everybody was talking about learning, relearning, etc., because you have to continuously learn. So that portal is available to everyone, where you can actually kind of know what is happening next, and then you yourself kind of keep updated on every process that you have. So that is what is, and it is very much personalized experience. It knows, as a any other Amazon or any website, when they know, they recommend what is to be bought. If you're buying this, you can also buy that. Similarly, this tool also is hyper personalized, and give us that experience. It understands what, as a user, what as an employee I am looking for, and what is my level, what kind of training I need. So it will come automatically. So that process is enabled, and then it is not only technology alone, but it's a reimagining processes that gives us that feel we get it. And next, we can also manage and automate. For example, every data, whatever we're getting, like in machine learning or any other structured, unstructured data that we do training, somewhere we have to data science. We have to develop different tools, what will work and what will not work. But nowadays, advanced automation tools are used through bot factory, and also it identifies some hotspots, they call it. Many of the things are not even known to me, where it learns what is to be eliminated and what is to be automated. And it, for example, somebody faces any issues, lot many tickets are raised for not getting the services, then all these processes are automated. The system knows, okay, this kind of technical issue is faced by the user, then you can the solution. You did not need any employee to work on it. Earlier, our employees were busy resolving the issues. Now also we have that, we completely cannot eliminate. But at the same time, many of the tickets which are known why these are kind of raised by the user, automatically system kind of takes care. So you can actually manage through automation. And last is very important, is the security part. At Infosys, we have a big unit itself for cyber security. Continuously, it kind of looks at everything is built by design. Now, all of a sudden, in the pandemic season, we had to kind of come back, work from home, and then many of our clients, we are handling very complicated and you know uh, kind of sensitive data. We are not supposed to work other than Infosys campuses. We have our huge campuses where we have data center, we call it DC, offshore data center, offshore DC. But, and then other than that, no one is allowed to enter there. But now, when after this pandemic had happened, so immediately a decision was to be taken how quickly you, and with full security, you can actually come and provide your services to the client. So we kind of kept on informing all our client what kind of security arrangements we are doing, and whether they are ready or not ready, whether they are having all whatever they want, they get, because each contract is different. So whether we are meeting each and every contract obligations, that was also needed to be taken up. So that's why I think when work from home, people are saying we work 24 hours actually. There is no kind of rest at all. And every Saturday, Sunday also, people are working, because initially more to actually set up the system to having secure system. All these things were built in. So for every process, the security is key. And this whatever live enterprise suite I'm talking about is actually a suite whichever I showed you a little while ago. This model, sorry, this one is actually an entire suite of live enterprise where everywhere each and every process is taken care of at Infosys. I'm kind of explaining our experience here, and then this we are also taking to outside our client, saying that this is what we have experienced, you can also experience through this model. So next is now also just wanted to share some of your our work in the current pandemic, where we have worked, because if I go to Infosys office today, sometimes I have to go. I don't have to touch anything. I have to stand in a place, and then from my facial recognition, I will be recognized, and I will be knowing, okay, this is this is me, because in my system I already have my photograph. And they will also send this, if somebody is wearing specs and somebody is not in a very good this thing, they will identify, the system will identify, and then they will also identify, take the body temperature, and kind of say whether you are allowed to enter in or you are not allowed to enter in. So this is one process which we are doing, and it's not moving. So this is another one, is again mask compliance, where this we have this tool wherever you anyone, if they are actually wearing the mask or not wearing the mask, people sitting in remote locations can actually identify, see through your CCTV camera or somewhere, and they can immediately give alert to the government or the authorities that this is where the compliance is not met. So this is the mask compliance which we can maintain. And this is again social distancing also. From this tool, we can identify whether someone is actually maintaining the social distance or not. This is the speech biometrics. In the speech biometrics, where you can actually just say your name, and then you can identify whether, okay, I'm Monisha, or who I am. The system will have my recordings, my sound recording speaker will actually have that. And after due course in time, the system will already, if I just say hello, they will know it's me, I'm calling. And then through that they will allow me to enter or not to enter. They will identify, they can do the verification through a speech biometrics as well. So these are some of the techniques which and then other one is about AI. So these I've talked about: facial recognition, speech, and social distancing, etc. The other thing which I was hearing our chairman Nandan Nilekani talking about, how we are going to adopt the vaccine strategy, because he's part of the committee here at Government of India who is working on a vaccine strategy. So we cannot actually imagine any strategy without adopting AI methodology. So digital orchestration platform is a must. And because we are talking about 1.3 billion, and I understand we may have to give 2 doses per individual. So we are talking about 2.6 billion injections, which may have to complete in 2 years. So it is not an easy job, but at the same time, technology is available through which you can actually do this. And we have to think about building a robust system which will be accessible, which will have universal access. It's not that only person who has a smartphone can only be able to, but many people in the village or otherwise, they may have a very basic phone or may not have also. So we have to cover each and every individual. So we have to come up with a robust system. We only not cannot only think about building everything digital. This digital, obviously we have to, but we have built in such a way that it has got universal access to each and every one. So that's how we are kind of, this is what is the need of the hour for vaccine strategy. And also AI will definitely help in identifying which pair of DNA vaccine is needed for which group of people. So that entire kind of grouping, subgrouping, etc., can be done by AI methodology through some simulation pathways, or whatever the experts will identify. So this is what the learning from pandemic, which I think it's a need of the hour to apply. And last one, which I just kind of, the main part is the governance part. Actually, although we are talking about AI tools, etc., but human involvement is still needed. I mean, it has to be always looked at, whatever results we're getting, although it's automated everywhere, but we cannot forget it. We have to have a human touch to actually see whether the results are accurate, whether it's biased data is not coming up all full to the optimal, whatever optimal data is needed, although 100% may not be correct, accurate, but to the extent possible we have to minimize that. And that's why we have to have human intervention all the time. And then AI is also thinking of, or which feature of the given input is emphasizing while making predictions. So we have through human intervention we also know which AI model is workable and which AI model is not workable, and what are the areas we need to improve upon. And also reproducibility. Machine learning process should be consistent every time when giving predictions, should not go haywire when testing any new data. So these are some of the principles which we are taught to follow when we kind of implement AI for Infosys as well as for other organizations. So thank you. I don't know whether I've taken more time, so I tried to quickly finish according to my time.
No, ma'am, you have not taken more time. You have
Okay.
completed within the
Well,
time.
okay, good.
Too early.
Okay. Yeah, I thought, I should kind of um, not take much time, because every 5:15 was the timeline given. It doesn't matter if this thing, but I'm open for. I don't know whether I was very fast. Was I too fast or
Yes, ma'am.
oh, I don't know. You please tell me. I can repeat any of the
No, no, no,
slides.
ma'am. No, ma'am. It is understood.
Okay, it's clear, no?
Yeah, it's clear, ma'am.
Okay. Actually, since I come from industry, I can only show you use cases. So I thought that let me, show use cases that we have applied, not any research papers. I hope that is okay.
Okay, ma'am. Thank you very much. And it is time for any queries. And she has given a picture in real-time situations and with respect to IT technology. And it is very really distinguished paper, madam. This presentation is out of all from the yesterday. We have been listening each and every technique. But though I am in mathematician or statistician, but these are the nowadays the latest technologies which are using to identify a critical problems of current scenario. Okay, it is time for questions. If anybody have any clarifications,
If you have
today,
ready.
madam is ready to clarify. Okay. Anybody? If not so, thank you very much, ma'am,
Thank
for,
you so much.
for enriching our knowledge with
Mhm.
respect to industrial experience. Very happy. And before uh, uh, turning to over to Professor Rajshekar Reddy garu, I thank both the speakers of today's session, which have really different topics and by which we have enriched our skills and knowledge. At least we can think over that to embedding both in terms of mathematics and operation research and information technology. Is there any combinational effect will be there out of these lectures? I hope this one. And finally, I thank Professor Rajshekar Reddy sir for giving me and involving me in this international webinar to enrich my skills and knowledge to serve my institution in a better way. Thank you very much, sir. He is,
Yeah.
ma'am, I would like to tell one more thing about him. And since my graduation and post-graduation itself, he has been encouraging me like anything to involve in
Yes.
such academic forums and scenarios. I thank you very much, sir. Thank you.
Thank you, Lavanya. I know that because since your association with War Society of India is very active, so I know about your keen on subject of war and other statistics also. Thank you, Monisha. After maybe
Yes.
97, then again it is
Yes.
2020. So after 23 years, now I heard about your sweet
Thanks to
war.
you, actually.
Yeah, thank you really. Okay, good day. Yeah.
Thank you.
Yeah.
Thank you so much.
So tomorrow morning by 9 o'clock sharp, there is this program. So we'll have it tomorrow. Tomorrow evening up to evening 4:30, we'll have the programs. So this is to today with this today's program. So we have closed. So thank you, Lavanya, once again. Thank you, Monisha.
Thank you,
Yeah.
sir.
Bye.
Thank you, all of you. Thank you.
Meet you tomorrow. Yeah, sure.
Thank you, ma'am.
Thank you, ma'am, so much. Okay.